How do ideas become industries? How do inventions become innovations? How do you break through? In this course on problem solving and new venture creation, you'll learn how entrepreneurs match promising technologies with customer needs to build successful businesses. You'll acquire new analytical skills as you navigate the complexities of the commercialization process, moving a technology from lab to the market. How will a technology be used? Is that technology ready? How will funding be secured? What is the business model? Throughout this journey, you'll hear from a variety of experts, including founders, funders, and industry mentors who will share their advice and experiences related to bringing new ideas to market. Many ideas never move beyond the lab, and those that do often fail to achieve commercial viability. How do we successfully match seeds with needs? Join us as we unlock the potential of promising technologies and their ability to solve some of our planet's most urgent challenges.
In many ways, I hear this buzzword that almost every company is becoming a technology company. All companies need sort of a technological footprint in order for them to succeed, even if you're a pizza company to you're a biotech. And my perspective is that, there's like inventing the breakthrough technologies, you got to invent them. But once you invent them in your lab or in your R&D department, you got to bring it to market. And this course is really designed to help our participants learn about what does it take to actually launch the technologies, launch the breakthrough technologies, and not just invent them. Invention is a separate process. Launching is a very different process. And we hope to sort of open up the black box of what it means to launch breakthrough technologies.
So in creating this course about launching breakthrough technologies, what we are trying to do is to build that road, access for technologies to move out of the breakthrough stage into the market so that they can get applied, adopted, solve real problems, and create value in the society.
Yeah, absolutely. And there's as much failure on the launch side as it is on the invention side, right? And I think people underestimate, you find something cool and awesome, and you think everybody's going to show up and buy billions of your widgets or of your service. But as we know from research, long-standing research, that actually commercializing technology, transfer technology is full of a lot of potholes, a lot of failures. One interesting statistic I heard was that only 10% of the good ventures actually even succeed.
And that is good ventures.
That's good ventures, exactly, right? So I don't know what percentage of ventures are good ventures, but even from the good ventures, only 10% succeed. So if 1 in 10 are succeeding, what we want to do is provide a basis for our students, our participants, to learn how to go about increasing the odds of commercializing those breakthrough technologies, launching those breakthrough technologies, and creating both ventures outside of companies, inside of companies, or even in nonprofit sectors as well.
Right.
Years ago, when I started teaching at Sloan this course in 2000, and they wanted me to teach a course on entrepreneurship, and I thought, well, you can't teach entrepreneurship. This is you can maybe learn it, but you can't teach it. And I realized I had this problem with the word entrepreneurship, is that it actually comes from the French word to undertake, which is kind of ironic because that means literally undertaker, which is kind of unfortunately where we find ourselves often as entrepreneurs, is you're kind of dealing with undertaking in the other meaning of the word. Yeah. But the real, the more serious part of what I want to say is this part, which is what I don't like is the ending of the word. So ship as the ending of a word in English often means the state of being something. Craftsmanship, leadership, friendship, sportsmanship, right? All these ships mean the state of being something. Now, I'm an engineer. I don't do engineership.
You do engineering.
I do engineering,
Yes.
which is the act of doing something.
yes.
And what I really find is an unfortunate remnant of the history of this field is that people are thought to be something versus do something, and therefore they spend all their time trying to analyze the history, the DNA, the character of people who do this. Whereas I think at some point people are going to realize that a lot of different kinds of people can do this, but this is entrepreneuring. It's not entrepreneurship. And as soon as society flips that, which is, by the way, happening right around us, all these incubators, mentor services, all these accelerators, all of these are, but when I started 20 years ago, that was not at all in vogue. You know, it's great to celebrate things, but after a while, you got to stop celebrating this because it shouldn't be this rare and it shouldn't be this hard. The reason it is that people often tell themselves, this is like a lottery, it's not going to work, and they do it without a lot of forethought. And that's, I think, why courses like this really should get people to say, I could do it by winging it, but do I want to actually have as my profession improvisation? I mean, if you want to do that, you can be a comedian, you can be a jazz musician, but the notion that you're going to improvise for a living and then take unsuspecting people's money and then let alone make something you put into patients to save them, just think about the juxtaposition of how we do entrepreneurship and what we do in entrepreneurship. Pretty big difference. So I think, I mean, I'm very happy that I'm living long enough to see this field literally become a profession. And part of the reason I used to call it parallel entrepreneurship is because it was kind of so ironic. What does it mean to do you can be one thing. How can we be parallel entrepreneurship, right? But once something becomes a profession, I think this is going to be, I think, my kids who are in their 20s now, but the next generation who does this will be more like a profession, like medicine, architecture, versus this sideshow that's celebrated and people are getting movies made and get rich quick scheme. It's going to be a profession.
What is innovation?
I think innovation right now is a burgeoning piece of the economy that has to do with taking the technologies and the tools and the learnings of the last 20 years and trying to put them into practice.
I think it's seeing a version of the world that doesn't exist yet and then painting a picture of what this looks like for the rest of the world. Then you have people aligned behind you and you can all move towards that vision.
I think of innovation as taking an invention and commercializing it and making it into a product or a company that is creating some value for society where people are actually paying for it.
I think innovation is a combination of two things. One thing is it's something new. It's something that hasn't been done before, right? It's unique, it's different, it's original. And two is it's useful.
Innovation is the activity whereby new products, technologies, ideas, techniques are generated, which sometimes displace or destroy older established practices or products.
From my point of view, innovation means problem solving, taking on an activity, finding a problem, and then going about and solving them.
Innovation, to me, is looking at really creative approaches to difficult problems and looking at them in different ways that others have done before.
Innovation happens usually with a person who is emotionally distraught regarding a current scenario or situation. This could be a user of a product or a user of a technique or a user of a practice that doesn't like the way they're currently involved in the ecosystem. They don't like the current technique or method for doing something, and they want to fix it or change it or improve upon it.
Innovation happens in a lot of ways. In the university context, you've got students that have really good ideas and they want to see those ideas exist in the real world. And there's a process around thinking through problem spaces and solution spaces and making that connection. and building something that is able to take some observed problem and connect that to some real world solution.
Is a soup kitchen who finds a better way to distribute food to the local population. That's an innovation. And somebody who creates a social enterprise that finds a way to generate a revenue model aligned with, that social impact, that's innovation too. I think it's important to appreciate how, in all these different contexts, innovation is taking place.
And what we are constantly looking for is new approaches to either halt the progression or to actually improve the condition of Alzheimer's patients. And to do that, we need to look at new approaches from a biological standpoint or new approaches from a modality, that is, a therapeutic, that is using a different type of technology to intervene with the disease.
So it's a new way of doing things, but still problem solving. And that's what makes it different from invention, which may not have a problem to solve as its fundamental goal.
For me, the innovation is defined as being different from invention precisely because you have taken that invention and commercialized it into a company or a product that people are willing to pay money for and to use, and that they find valuable, not just you.
We use 12% of all U.S. energy consumption, separating different chemical components from one another in the manufacturing sector. So this could be everything from fertilizer to plastic bags to medical devices. And the amount of energy is equivalent to all the gasoline used in all the cars and trucks in the United States every year. So the magnitude is enormous. It's in all these different sectors. And that paper said, well, if only we had better membranes, we could start solving this energy challenge. We could reduce the energy used for this by 90%. And we said, well, if only we had better membranes, and we have a over-engineered membrane over here, is there a good fit?
Sometimes you solve big problems, which are things like inventing quantum computing, but actually bringing them to market, or inventing, the next generation of mobile phones, the iPhone, and bring it to market. That's, breakthrough innovations. Or it could actually be something simpler, which is improving your factory process flows.
It always comes back to a person who wants to fix, change, improve, modify, disrupt a current ecosystem.
I think that innovation comes down to wanting to do something just a little bit better.
So tell us what Flagship does.
Yeah, so that's Flagship. Flagship is first and foremost a life science innovation company. We have our own way by which we innovate, which I'll tell you about. Yeah. Once we come up with something that's worth taking forward, we form a company to take that forward. And so we also had to figure out how to do venture creation in a systematic way. We have our own capital, then we deploy into these companies to help them grow for the first 2-3 years. So up until then, they operate as wholly owned pieces of Flagship. And then we spin them out. And we spin them out, and for the first time, additional capital comes in. But by that time, the culture, the senior leadership team, the early proof of concept, the early kind of customer or partner traction is there. And it looks like a company ready to eventually live its life on its own. So we're not interested in building kind of subsidiaries open-endedly. Every single thing we do ends up becoming a company or nothing. Yes. But so we've become kind of a creator of companies around internal innovations. Now, sometimes these innovations draw from external science, and I can describe that. Yes. But we're not only trying to find science and then find what to do with it and create companies. That's become in vogue the last few years. We've been doing this for 18 years. But we've ended up in a place where we think the sustainable way to do this is to have your own innovation capacity, your own company creation capacity, initial growth, and then the companies have the wherewithal to grow and compete and thrive.
That's fascinating. So walk us through one example of a company that you guys have given birth to from the start to, it's leaving the flagship full?
There are many. I think we've been involved in doing about 50 of these that are based on internally developed science, and there's a whole bunch more that also include external. But I'd say one of the internally developed ones that just recently went public, I can give as an example, is Moderna. So Moderna was and I'll tell you kind of this. We have this fairly, let's say, prescribed process, which the way people think about entrepreneurship and innovation, especially breakthrough innovation, is that it is unruly, it is chaotic, it is inspired. And
serendipity.
In my view, it's none of those things.
It's none of those things.
Absolutely none of those things. I have a completely contrarian view of that, and I've done it enough times in enough different fields that I think, frankly, just to be a little controversial, I think that's an illusion. In other words, I think that because people haven't done that thing before, it's exciting and unexpected to them. But actually, pretty quickly, it looks like just another version of what came before them, because the historians come and say, well, before there was the iPad, there was the iPod, and before that there was the Walkman, etc. And also, when you look at it that way, you go, well, why were you surprised? And that's when you realize that these things are just evolving. And so I'll give you an example in this company called Moderna, but before that I'll tell you that underlying how we think you can do this systematically is the notion that breakthroughs aren't made by people, they emerge. And the most understood, not well understood, but understood version of emergence that we know about is evolution, which is that if you do variation, iteration, selection and iteration systematically, the winners will emerge, and when they do, they will look surprising, but actually they're the result of that process. They're not some inspired thought that has nothing to do with that process. So hold that thought as I give examples. There'll all be examples of that, and that actually does cause one to think differently about being possessive about all these companies and all these innovations. We're not. We don't go around saying we invented this. We may file a patent and get an invention, but where these ideas come from are very emergent. So in Moderna's case, talking about emergence, we understood by following the various scientific advances that people were playing around with converting fibroblast cells into what's called induced pluripotent stem cells. These are, somebody won a Nobel Prize recently for this. These are called Yamanaka factors. So it turns out that if you take differentiated cells and you introduce a couple, 3 different proteins, 4 of them specifically, these cells can de-differentiate and look like what came before them, stem cells. They're not normal stem cells, but they're close to being stem cells. And so why do that? Because then you can differentiate it and make other cells. So that was the general field. And in that field, there had been some people, particularly at UPenn and then more recently at Children's Hospital here in Boston, who had been playing around with using what's called mRNA, messenger RNA, to use these to go into cells and express these proteins. Why had they done that? Because it turns out this mRNA, they could actually get a better transformation of these cells. And so we were aware of this work. And we started asking kind of just what-if questions.
So your team is reading scientific papers, it's in the air.
Yeah, in this case, exactly. And we do this all the time. So basically
You're in the mix of this flow of knowledge.
Exactly. It's not about reading papers for us as much as just, we are talking to lots of people about lots of different things. And then or somebody says, hey, by the way, I just saw this data. And then we actually read papers in hindsight. In other words, we read papers once we have an idea of what to do, as opposed to read papers to get an idea per se, because there's, the signal to noise in papers is gigantic. You can't, if you sit there and read 1,000 papers and that gives you 3 ideas, hard to do anything else. So I'm sure that can be done too, but that's not the way we approach it. Anyway, so long story short, we started wondering, for lots of reasons that I can't almost reproduce, because you'd have to go back to 2010 in the summer and whatever else was being thought of at the time. So understand, by that time we had about 20 people that were doing this type of activity in various combinations for a living. And so it's important, because these ideas kind of get mixed and moved around. This is not a one person thinking deeply is not going to get there. So we started asking, can you think about, we started, why isn't there no drug that is based on mRNA? Now, if you go back 10 years, drugs were made out of proteins and small molecules. There had been an effort to use viruses to introduce genes into the body called gene therapy, and a person had died early on, and that whole field was shut down. And there really was no other variation to proteins and small molecules. And there had been some efforts to try to make, not to get too detailed, but other small DNA, RNA molecules, antisense, what's called, and we were aware of all this, but we're saying, why don't people actually use this microRNA molecule? And that's just a thought experiment, and you can go and answer that question.
So you raise the problem.
You raise a what-if problem. You don't say, initially, we don't start with, we need to cure melanoma. We don't start the problem, what good is this mRNA that can transform cells, because it's not good for anything other than that. Yeah. But we kind of abstracted and said, is there a combination of a solution and a problem that we can identify simultaneously around this space? And if there isn't one, then we move on. And in this case, that's part of our methodology. In this case, what we concluded was that people had tried and failed 10 years earlier. We understood why they tried and failed. We realized that there was no obvious fix to it, but there was a directional fix in that you could modify chemically some of these RNA molecules, and they at least hinted that if you kept doing that, there may be better ways. We had no proof. There was no academic literature that said this can be done. Now, we could have waited for that, but we probably would have been 5-6 years, because now there is academic papers from which we could have started companies. Sure. But our whole thing is to almost mine this science of the future to try to solve problems of today versus mine the science of today to solve problems of the future. And that is exactly backwards. Yeah. And it's not any better. It's just that you look at the world differently. So publications give you evidence for what you want to do, but that's not why they published those things. They were thinking of a very different thing. Problem, yeah. Do you know what I'm saying? So in that regard, that's a little bit. So in Moderna's case, we identified. Well, the other thing that we do, a very integral part of what we do, is that we don't do this in a vacuum. So we go out and talk to people about our hypotheses. These are not.
And you're not afraid of people taking your ideas?
No, and I'll tell you why. So we have this. So we use, in order to try to create an evolution. So we're trying to create an evolutionary environment. How do you do that? The scientific method uses hypotheses and experimentation. Yes. So we actually do the same thing. We create value hypotheses. We basically say, I will take an mRNA molecule, formulate it with this agent, stick it into muscle, use muscle to... None of it is true. None of it has been done before. But it's just a starting point. We then go with that to a handful of folks that are both experts and non-experts in the field. Super important thing if you're going to practice this kind of work is that experts actually are not the people who are going to give you an idea of how to do things dramatically differently, because they became experts by already doing something dramatically differently, and now they're defending their territory. Yeah. So if you go to talk to somebody and say, can this be done out here? Most people we talk to, they can tell you precisely why it can't be done, which is really valuable from a selection pressure standpoint, but not the source of kind of, and here's a completely different way. So other people, though, who don't have expertise but have interesting creativity, so what we do is we take our hypotheses, and it's never one, because one of the things we've learned is that if you start with one starting point, you only locally search the space around it. So we sample multiple different points. So it might be, how about mRNA as a way to make more proteins in a fermenter? How about, so around the theme, we come up with totally different value pools we try to identify. And then we put a starting point, and then we start talking. And what's been interesting and a great learning exercise over the years that we've seen is that if you go to somebody with a bad idea, but you actually present it in a precise way, they will tell you why it's a bad idea. And in that transaction, something happens, they feel smarter, and you get selection pressure. Yes. And so the way our process works is that we actually do this with multiple people. So when you said, aren't you afraid they're going to take your idea? What are they taking? We just made it up. Yes. There's zero fact to it. Yes. Literally zero fact.
You're just imagining it.
Exactly. We're just a hypothesis, and they know it. Yes. Because then they tell us, what proof do you have? I say, none. Yeah. So then they still engage, because it's almost, when we talk to these folks, and this is what we're known for, we create a bit of an expert-free zone in the sense that you see. Look, these scientists, here we are at Harvard and MIT, Stanford. These people go to the meetings of their fields, and they cannot say something that does not seem unbelievably smart and reasonable. Actually, I'll make the point. Let me caveat. Reasonableness, in my view, is like the gravitational force that keeps innovation from happening. Because people enforce reasonableness in the scientific world on what you are allowed to say. You go publish something in literature that's not reasonable to the reviewers, you can't publish
You
it.
get killed.
So
I've done a whole study on that.
Right.
Yes.
So ask yourself the question, why is it that we think that the only innovations worth working on start their life reasonably? In fact, I can show you many innovations that are now accepted as real transformative things. Every one of them started life unreasonably. And yet, we go look for them in reasonable places by reasonable people who are using reasonableness filters to kill them. So because we knew that, this was not the first thing I had done, we kind of say, look, let's forget reasonableness for a second, just think with us. And they tell us, bad idea, somebody in Japan had tried it, the experiment won't work. And we keep tweaking and tweaking and tweaking. This is different than kind of like you hear a lot in Silicon Valley speak, kind of pivoting. This is not pivoting. Evolution is the master pivot. It's like non-stop pivoting, right? There's nothing to pivot from and to. You're just adapting and surviving. So that mindset is super important. Now, what happens is over time, things emerge, or they don't, but they emerge where the next person you talk to goes, they can't find fault with it. You know that because it frustrates them.
Yeah.
And then they start telling you, well, do you have any proof? And you go, no, I just made this up. It's just that we've been iterating. And then that point is when we go into a lab for the first time. And then and only then do we test the idea. Now, you can't test it fully. You can't test it where, because it takes years and years. But we try to, and one of the expertise we've developed over the years is how to figure out what to test first. And this in life science, you can't use these words, killer experiment, because, life science you can kill. But you want to do the killer experiment early.
Yes.
And so figuring out what's the killer experiment, or 2 or 3 or 4, that if it doesn't fail, allows you to go forward, that's the trick. And we do that in our shop. So in Moderna's case, we spent a couple $1 million, about 6 months, doing a set of key things, but for which we would not have proceeded. So we knew the idea had morphed and evolved and it had some resilience to it. We went into labs and asked specific questions. Once we saw that actually some of the things we were hypothesizing could be done, partially, we then decided, okay, let's form the best economic value creation engine known to mankind, which is a startup, in my view. I'm biased. And then we deploy that startup to go after that value pool in as many different ways as we can.
There's a ton of hype around innovation, entrepreneurship, commercialization. Thousands of books are written every year about this topic. But let's cut through that hype and focus on what really matters. When we're innovating, when we're commercializing, when we're being entrepreneurs, we're engaging in problem solving. That's the thing that all of us do when we're taking on these activities. And so in order for us to become better at innovation, at entrepreneurship, at commercialization, we want to become better at problem solving. And thankfully, we have 50 years of literature in the cognitive sciences, in psychology, in sociology, and economics that's tried to make progress around how people can be effective problem solvers. And one very powerful approach is to think about problem solving as a search process. You're searching through a landscape for solutions. And this approach is very helpful for us. And the way to think about this is that a searcher, you as an innovator, as an entrepreneur, has to have 2 things to be effective. One is a perspective. How you represent the problem you're going after, how you're defining the landscape that you're going after. And then secondly, you need a heuristic. How do you then find your way through that problem-solving process and find an appropriate solution? How do you traverse this landscape? So innovators go through creating a perspective and a heuristic pair when they are solving problems. So let's now make this fairly concrete and specific and make this accessible to us. I want us to go back to your high school days when you were learning trigonometry and you were learning various ways to do math and algebra and geometry and so forth. One of the things you might have learned about has been like the Cartesian coordinate system. Really what was being talked about was how do you represent objects in what's known as Euclidean space. Now, there are two different ways to represent an object. You can use Cartesian coordinates, if you remember x and y, to represent an object, or you could also use what's known as polar coordinates. You can represent an object by a radius and an angle as well. So depending upon the object you're trying to represent, you might have a different coordinate system. You might use a Cartesian system to represent a rectangle. It's fairly simple and easy to do. But if you were to represent a rectangle through polar coordinates, it'd be very difficult. Similarly, if you took a circle and tried to represent that through a Cartesian coordinate system, it'd be very difficult, but it's very simple through the polar coordinate system. What this is telling us, this nice toy example is telling us, is that any problem, any technology in what we care about can be represented in multiple different ways, multiple different perspectives, and multiple different heuristics. And so what may be tough and difficult in one perspective and heuristic pair may actually be super easy to solve in a different perspective and heuristic pair. And so for entrepreneurs, what we want to do is find ways to generate multiple perspectives and heuristics on the same technology, because the choice of the perspective and heuristic that you're going to go after is going to, in many ways, define the difficulty that you face. And certain problems could be novel and difficult and even unsolvable with one perspective, but then fairly easy in a different perspective. The Euclidean space examples of the power of alternative perspective heuristic pairs shows us how some problems that are hard in one perspective heuristic framework can be relatively trivial in another perspective and heuristic framework. So let's go beyond the toy example of finding objects in Euclidean space, and let's look at the world of life sciences. Here, you can imagine again that different perspective heuristic pairs will be very helpful in solving core problems in life sciences. If you think about the world of neurology and brain problems, we can model the brain as a biological organism, we can model the brain as a chemical engineering organism, or even we can model the brain as an electrical engineering problem as well. Depending upon the perspective heuristic that we apply, some problems will be easier in the electrical engineering framework versus some will be easier in the biology framework. And in fact, we see this happen quite a bit in epilepsy. In epileptic treatments, you can do electrical stimulation to alleviate some of the symptoms, or you can take drugs that affect both your chemistry, your brain chemistry, as well as your biological features to help alleviate epileptical episodes. And so in this case, what we see are, depending upon the perspective heuristic framework, we can be more or less successful in solving problems that people face. Another example in life sciences comes from synthetic biology. Here, protein folding is a major bottleneck when it comes to making progress in discovering new drugs that impact the human body. And oftentimes they're faced with large bottlenecks for computational processing. A paper published in 2005 showed that methods that were well understood in material science could be taken and ported over to synthetic biology to drive massive improvements in performance, orders of magnitude improvements in performance. This happened because a postdoc saw some stuff in a material science class. He was taking that as a side project and took those methods that were commonly used there, and then when he brought them over to protein folding, had a massive impact. Here again, what we see is the power of an alternative perspective heuristic framework being applied to within the synthetic biology world, importing something from a distant field and bringing it in to the field that you're participating in. Let's go to one more field. Let's talk about something far away from biology. Let's talk about the world of finance. In finance, there's a history of importing perspectives and heuristics from physics and engineering to solve tough finance problems. So in 1959, Osborne showed that the market could be best understood through methods of Brownian motion. Brownian motions is a core part of how we understand physics, and Osborne brought that perspective to understand financial market data. More recently, Black-Scholes won a Nobel Prize for their option pricing equations. And their initial cut on this option pricing work was very complicated and hard to solve. They met some folks in mechanical engineering, and they looked at those equations, and those guys said, oh, this is basically a heat mass transfer equation, and here's how to solve the problem. And so what was very tough for them with one perspective heuristic framework became easily solvable with the heat mass transfer framework that the mechanical engineers taught them. All of these examples show us that entrepreneurs are going to be better off by systematically thinking about perspectives and heuristics for the seeds that are being created that they have available to them, and then use that to generate new options in the marketplace.
Well, so for me, it's like, we want to do the science. I mean, the number one thing that's always driven what we do is doing good science, irregardless of the need. In other words, I think discovering things and inventing sort of broad conceptual things, what I'll call platforms that can be applied to a lot of things, that's kind of what we've done. And we haven't, when we sometimes started these things, known exactly what the application would be. But certainly it was in my mind that there's the potential for a lot of applications. So that's sort of the first step. The patent seems to me, if you're doing something in a lot of areas, particularly the medical area, you need a huge investment of money to get it out to the world. And investors or companies aren't going to give you a huge amount of money unless they feel protected, unless you have a patent. So certainly in the biotech space, without intellectual property, it's very, very hard to raise money. And so I would see that we could raise that money from these patents, get a company started, and that would enable us to get these technologies manufactured, developed, and produced. Now, how do you figure out the right application? I mean, that to me sometimes is a big challenge, and it's a team effort. So we often don't know what the right application is at the beginning. So, we brainstorm a lot. Sometimes we talk to different people who are specialists in different areas. Sometimes there's consulting companies that we work with that help us try to figure it out. But you can apply them to many things. And I should say a lot of times, some of the initial things that we've thought about may turn out to be wrong. But it doesn't matter. Sometimes you'll work out a lot of the bugs on that, and you'll figure out the manufacturing processes, and you'll learn a lot, and then you can apply that to other things. Now, that's not the only way we work. Sometimes people have come to us with specific problems, and when they do, and if those problems we feel are important, then we do something that's more directed. But I'd say more often than not, we do something that doesn't have a specific application, and then we try to figure out the market later. But we feel that what we've done is really good science, and that's what we want to do as an academic unit. Well, to evaluate whether it's great science, I mean, I guess that's a judgment call, right? First there's the idea, and then there's how you do the experiments. I would say one way to do it, not that I necessarily want to have an outside validation, but if I were looking and I didn't know the area, what I might look at is the quality of journal that they published it in. So one of the things that we've done a lot is publish things in journals like Science or Nature, that are very hard journals to get into and are often critically reviewed. That doesn't mean they're right, but that's a starting point, if somebody's published something in a good journal. I mean, so I think that might be a first step to looking at whether you've done the first thing. And then maybe there's additional papers, and you can look at the quality of those papers and the quality of the science. I think there are a couple different things. First, when do we make a decision to spin it out? I like to think that I think we want to advance it to a reasonable degree. Like we've published a paper, we've filed for a patent, if we're doing something in medicine that we've shown it works in an animal. And if we've done a lot of those things, what happens, I think, in the lab is, since we have spun out a lot of companies, and a lot of the students here have seen older students or earlier students spin out companies with me, then it just kind of happens because they see that others have done it, and they might ask me, well, can I do it? Or can they do it? And if we've developed these things far enough, and then I might introduce them to some people who are venture capitalists, and then we go from there. I think diversity of viewpoints is useful to the process that we use. I think you want to make some distinctions. First, there's what you do in the lab. I think what we do in the lab, because we often want to take our ideas pretty far along in terms of proving them in an animal or sometimes a person, that takes, they're having people with different skills, including medical doctors, that makes a difference. I think at a company, the diversity is going to be far greater. And I think if you really want to get a product out, you need a company for the most part. I mean, we might provide the nucleus for that company, but the company, of course, will have business people, financial people, manufacturing people, all kinds of different people. And I think you need that diversity if you're going to get a product out.
It turns out that every industry has the same basic rule of don't get married to your favorite ideas, or don't fall in love with your favorite ideas. In Hollywood, when writing a script, I believe it's called killing your darlings. If you have a character in the script or a plot twist that you've fallen in love with, and the whole movie seems to be revolving around it, you're going to destroy your own movie. In engineering, it's keep it simple, stupid. Don't overcomplicate the thing that you're building. So don't fall in love with your own ideas is like rule number one, and that's pervasive throughout life. To don't stubbornly cling to something that just because you're enamored with your own creativity. That's a pretty good skill set, a life skill set for everything, not just entrepreneurship, but everything that you do. Now, some people will say, well, if you don't have conviction on something, the greatest inventions in the world only came out of somebody who had irrational conviction about it. Okay, understand that's 1 in 10,000 people, ride irrational conviction to the finish line, and the other 9,999 people don't. They wind up on the scrap heap of history.
Invention activities are focused on breakthrough advances, often unconstrained and not worried about applications. They're really pursued intrinsically, with intrinsic motives. Innovation, on the other hand, may be seen as the translation, the adaptation of these breakthroughs to address some real market needs. In fact, we might think of invention itself as a special type of innovation that is pursued for its own sake without worrying about commercial impact. Or we might think of invention as the upfront activities that are producing the seeds, the breakthrough inputs to the innovation process, which must ensure then that some compelling needs are identified for impact, for market adoption, and for customer usage. Now, consider our innovation processes of the last few years, especially used in our industries. Since innovation involves bringing new approaches and technologies to fruitful application, it can happen in one of several pathways, at least a couple of major pathways. Throughout the 20th century, we have had a more technology-driven innovation approach, where a company such as Intel, for example, works really hard to find matching applications for advancements in transistor technology that was originally invented at Bell Labs, but now governed by their so-called Moore's Law, which really is their aim to keep this technology advancing. We can call this a seed-driven or a supply-driven innovation approach, where the advancements in transistor seeds are really pacing this particular area. Intel, Qualcomm, and their peers engage in furious development of this transistor technology and create products to work with customers such as computer companies and cell phone handset companies to get these innovations out and tightly design them for application and for adoption and usage. In this case, the transistor as a seed really drives the innovation process, but you have to find new applications such as smartphones. This is seeds-driven innovation, starting with the seed and finding applications. During the last 20 years, we have had a progress on another approach we might call needs-driven innovation, which places high emphasis on starting with the needs, doing extensive studies of the market to identify, to unearth, to capture customer needs, which are then used to find a solution. In this case, we start with the need. We swim in the fishbowl with the customers. We really spend time in the field to find out what is bothering them, what their problems are, what their pain points are, and then try to discover new technological approaches to solve these problems. Which is better, the needs-driven approach or the seeds-driven approach? Well, it depends. There are merits to both these approaches. There are also significant challenges associated with solely using one of these approaches. We will argue that using just one of these approaches is like clapping with one hand. And if we really want to have impact, we really need to integrate them in a closed loop. That's what we'll call accelerated innovation. We'll discuss each of these approaches in greater detail and then learn to put them together. Seed-driven or supply-driven innovation is the name we'll use to refer to approaches where the drive for innovation, the push for innovation, starts from the supply side. In this case, you look at the new technological approaches and capabilities that are emerging from our labs, like transistors, new algorithms, gene sequencing methods, gene editing methods that we as a society are developing, and ask what major problems could we solve now with these capabilities. And we could do them much more efficiently and effectively than the incumbent solutions that we have today. In some cases, it does involve what is called applications innovation, that is finding suitable applications that could actually benefit from this new supply capability. In other cases, it may even require some adaptation, some recombination of these newfound supply capabilities, evolving them to solve the problems at hand. Most highly successful companies in this area, like an Intel or a Qualcomm, that have unleashed the microelectronics revolution, the transistor technology, have taken this approach where they have used this supply capability to find new applications and solve them effectively. Seeds-driven innovations, these supply-driven approaches, may look like a hammer in search of a nail. That's one of their problems. But in some cases, the bottleneck or constraining factor is not really the needs identification. There may actually be a number of well-understood needs that are captured, but it's really solving them and achieving order of magnitude improvements that is essential for adoption of these new innovations can actually be done if we have compelling seeds, supply-driven capabilities. It is true that we must tightly blend the seed-driven capabilities, supply-driven capabilities, with the market and customer discovery and needs identification processes in order to realize a powerful innovation outcome.
I did my PhD in mechanical engineering, but I was doing research in a material science lab. And that actually really allowed me to do a lot of different interdisciplinary things. I was working with a lot of material scientists, so I had a different perspective on things. I learned a lot about chemistry. I really hadn't taken chemistry since I was a freshman in college, and so I had a really wonderful learning experience as a PhD student. We were focusing on developing membrane materials for water desalination. So the vision was to reduce the cost of water desalination so that we could get fresh water to more places in the world more economically. And we were going to do that by changing the way materials were used for the membrane, for the actual filter that takes the salt out of the water. We developed a membrane. We kind of looked at things from how we could scale things up in the future so that we could look at costs and things like that. And then we looked at the impact that the membrane performance would have on cost. And that's when it started to get a little confusing because it turns out that there wasn't a lot of impact. And so we had solved a problem that nobody really had. So as I mentioned, I defended my PhD saying that this was a cool research idea. We were not going to be commercializing it. Thank you very much for my PhD. I'm going to go spend 3 months at the beach. And eventually that week read a paper about chemical separations and how we use 12% of all U.S. energy consumption separating different chemical components from one another in the manufacturing sector. So this could be everything from fertilizer to plastic bags to medical devices. And the amount of energy is equivalent to all the gasoline used in all the cars and trucks in the United States every year. So the magnitude is enormous. It's in all these different sectors. And that paper said, well, if only we had better membranes, we could start solving this energy challenge. We could reduce the energy used for this by 90%. And we said, well, if only we had better membranes and we have a over-engineered membrane over here, is there a good fit? And spent that summer not at the beach, but instead talking to customers across about 15 different verticals and deciding that there was a good fit, that there was a product market fit there, and that we were onto something and could go back to the lab and work on the technology. So that's what we did, and then we started this company kind of towards the end of that year.
Dr. Sam Kogan, thank you so much for joining us today and participating in our module as a guest lecturer. You are the CEO and founder of Gen 5 Group, and you help advise lots of companies with their innovation processes. So tell us a bit about yourself and what your company does.
I'm glad to be here. So in my background, I'm a physicist. A classical scientist, I would say. My master's degree in material science and PhD in polymer science. And for years, I was working and then running R&D organizations in big chemical companies. My last achievement was developing a new process of making Teflon type polymer. But 20 years ago, I completely changed my life. And since that, I've been in the field of innovation. Helping big companies and startups to develop and commercialize new products and new technologies. I've been lucky working with an exceptional group of scientists, engineers that all use the same methodological approach to development and commercializing products and technologies. And the essence of our approach is a functional view on the world. We look at the world as full of functions rather than objects. And this allows us successfully work from potato chips to electronic chips industries, from nuts and bolts problem to the big strategic problems.
Fantastic. So tell me a bit more about functional thinking, how it came about, and how you discovered it in your own work.
So functional thinking was formalized in late 40s by Larry Miles, who worked in the purchasing department of GE. And he wanted to get the best deals for GE when they were sourcing parts and materials. So eventually he developed a value engineering approach, looking at usefulness of the components or products or materials that we're buying versus what it would cost them. And it was great theory, and that was used by a lot of economics. People from purchasing, from financial, and so on. And in late 60s and 70s, a group of thinkers and scientists and engineers around the great Soviet inventor Henry Altshuler developed functional approach that they used toward engineering systems, as they call it, technical systems and products. And this functional approach allowed them to create functional architecture of the problem and solve it differently. I'll give you an example of simple wrong use of functions. NASA, as they say, spent millions of dollars in developing a new pen that will work in space when there is no weight, right? So normal pens would not work.
Because like the microgravity, gravity doesn't exist in space, and the ink won't flow down. Right?
So they spent millions of dollars in developing this, and they created a new tool that was called pencil. If they started from the very beginning and said, what is the function of the pen? It's not to move ink. It's to leave the mark on a surface. And there are other ways of doing that.
So just on this example, they were focused in on moving ink as what the pen did, instead of thinking of the function of the pen, which is really to leave marks on surfaces.
Absolutely. They were focusing on objects, on components. And functional thinking allows you to step back and look at the generally how you describe this function. And basically, functional approach, what attracted me to that, and once again, what allows us to really move from pet care to aluminum wheels, from gas turbine to diapers. What allows this, a functional view is Esperanto for engineers and scientists. It's a universal language that we work with aluminum company that was making aluminum wheels for big trucks. It's a huge 18-feet wheel, and they needed to cool it, right? And we brought a technology from the semiconductor industry that where you cool micro elements of the chip. Why? Because the function is the same. Components are different, but function the same. I'm still kind of excited and have chills every time when I'm thinking about that and try to identify what is the function here? What is the reason for this product or this component to exist?
In the language of our course, in the framework of our course of perspectives and heuristics, my sense is that the functional thinking enables entrepreneurs to come up with new perspectives and new heuristics on how to solve a particular problem or take a technology and find different applications for it.
Yeah, absolutely. I'll give you an example. So one of the biggest consumer packaged companies in the world was developing a new nasal filter against allergy. It's one of the biggest companies. They put enough resources, people, money, and they were still struggling because they could not solve the problem if you stop all allergens, you cannot breathe. If you could breathe, everything goes through. And they try to optimize the materials and so on. When we step aside and said, what function do you need to perform? And it turned out that the function that you need to perform and solution to the problem that you need to perform, how to create a strong vortex that will throw a tiny particle toward our mucus. Naturally, when we inhale, we create this vortex, but it's not strong enough for the tiny particles. So we did, as we call, function-oriented search, looking at where else people perform this function. And you usually look at the industry where the life and death for the business or the person to perform this function, because if it's a life and death, you could be rest assured that they would know everything. And we found that in pharmaceutical industries, they cannot throw tiny nanoparticles in the atmosphere because it will create lungs problem and so on. So a small Israeli company have developed a technology that creates additional vertices that will separate tiny particles in a tower that probably 5 feet or 5 stories tall. And we solved the adaptation problem rather than the invention problem. And the reason why we could do it, not because we're smart or successful, but because we looked at the functions and solve adaptation problem rather than invention. So what entrepreneurs need to do is the same. Look at the technology they have, define the value drivers and the functions, and look where else people need to perform similar functions and apply it there. So once again, I'm very excited that we will be able to introduce this thinking to your course.
Thank you very much, Dr. Sam Kogan, for joining us today and for giving us your insights on functional thinking. We look forward to learning more from you.
Let's talk about innovation. Different people define innovation differently. But let's us be non-orthodox and first define what innovation is not. Innovation is not an invention. It's critical. Innovation is not an invention. Invention, it's all about technical or scientific discovery. When the patent office looks at the patent application, they looked at 2 parameters only, not obviousness and novelty. Therefore, they grant probably 75% of patents that they grant represent nothing. They will never see a commercial value, and some of them are just stupid. I could name you a few. Umbrella for your shoes, for example. And there are patents that even the best of inventors have developed that never became an innovation. Edison, for example, developed an electrical punching pen that would punch hole in a paper. It never seen the light of the day. There are great inventions that have not been successful. At Segway, there was a lot of hype about Segways, but besides few cops in the mall or on the airport, we have not seen successful application of this technology. Some great inventions take time to become a commercial success. For example, fuel cells. This technology was invented at the beginning of last century, and it took 60, 70 years before this technology was commercialized. And at the same time, we know about great invention that became great innovations. Crest white strip. This was a great invention that really go well beyond whitening toothpaste that existed back then. iPhone is a great invention that actually combine a lot of known innovation from the different areas. The single banana that you could buy at the airport or at Starbucks is a great example how cutting technology of a single banana from the bench became a great innovation. So when we talked about commercialization, we have to clearly understand that we need to look at technological advancement, but we must move technological advancement toward commercial success through identifying and advancing the value on the marketplace. As we discussed before, any successful commercialization of technologies should be guided by three major principles. First, it's all about innovation, but not invention. Invention is about creating technical novelty. Innovation is about creating value. Second, it's about main parameters of value, which are the attributes of a product and technologies that drive purchasing decisions. And last but not least, it's about function. Function is the goal, technology is a mean. These three guiding principles of commercializations could be used for different applications. Today, we will talk about one of the most difficult and important one, is finding new applications for existing technologies. The benefit of finding new application is obvious. It's growth. New application for existing technology could fuel this growth and help company to prosper. But why it's difficult? There are a number of reasons for that. First, resources. Nobody has unlimited resources, neither people, no money, no time, so we cannot boil the ocean. We need to find a way to be successful using limited resources that we have. Second, finding new application is not about finding technical solutions. It's about finding applications where our technology could address new parameters of value of these markets. And last but not least, it's all about creating value for the end users or the customers. So as I said, it's not an easy process, but we should not give up. There is a structured process that we will discuss that help all of us to go through this difficult process of finding new application for existing technologies. This process consists of 4 major steps. And each of these steps, we will be answering on one major question. So let's look at them one by one. First step is discovery. In this stage, we will answer on one major question. What are we looking for? We will define our technologies and prepare it for the search for new application. But we will define it using functions and parameters. The second stage is called search. This is a kind of a normal search for new application, but we will use functions and main parameters of value as a new taxonomy of this search that would allow us to focus our search. Third stage called synthesis and selection. In this stage, we will look at all possible applications that we have found
and decide which ones are the most promising, which one could create the highest value for end user or customers. And finally is validation. In this stage, we will need to answer a very important question: what needs to be done to successfully apply our technology for this new application? So, 3 guiding principles: innovation, main parameters of value, and functional approach, used to address one of the most challenges issues of any research organization: finding new application for existing technology.
The prior example of how perspectives and heuristics, alternative perspectives and heuristics, can create breakthrough solutions in the field of finance or in the field of protein folding will probably raise a couple questions in your mind. Probably you're skeptical, saying, well, first of all, it was pure serendipity that Black and Scholes ran into some mechanical engineering professors and they were able to trivially solve their complicated equations, or that a postdoc just happened to, by accident, take a class in material science and then solve the R&D problem in protein folding. And so serendipity might be the answer, and it's hard for us to engineer serendipity. Or it could just simply be the feature of the university environment where we're very lucky to have, by definition, multiple perspectives and heuristics across the faculty. For those of us that are entrepreneurs, that are innovators, that are commercializers of technology, we may not have ready access to diverse perspectives and heuristics. So how do we solve this problem? Over the last 15 years, my core research area has been how crowdsourcing, how going to the crowd for solutions can in fact open up diverse perspectives and heuristics through potential participants from different knowledge domains. Crowds can do this systematically, and today crowds are available on demand. A great example of this is a company that was stuck with a chemical engineering problem that needed help. In particular, Colgate-Palmolive, the makers of the Colgate toothpaste brand, had a new formulation of fluoride for their toothpaste. And what they were concerned about was that this new formulation of fluoride was being dispersed into the atmosphere. And they didn't want to have that happen because of both the wastage and efficiency issues, but also the environmental issues that go along with it. So this new formulation was stuck in the lab because the R&D team could not figure out a way to prevent this dispersion. So finally, in desperation, they posed this problem to a platform called Innocentive to have this problem be solved. Innocentive is an online marketplace established by Eli Lilly to help their engineers and their scientists source diverse perspectives and heuristics from around the world. Innocentive put this out as a challenge with a prize amount. And basically, Ed Melarek, who was an electrical engineer in Canada, came up with this winning solution. Now, what Ed thought about, when Ed saw the problem, he immediately went to a perspective and heuristic pair that was not in chemistry. He was an electrical engineer, so he used a physics-based, electrical engineering-based solution to this problem. And this solution was pretty darn cool. What he did was he said, all you need to do is add a positive charge on the fluoride powder and negative charge or ground the tube, and all of a sudden there won't be any dispersion whatsoever of the fluoride when you try to mix the toothpaste with the fluoride. For this effort, he got $25,000 prize, and he only spent a few hours outlining the solution to this problem. But what it shows you is, again, the power now of the perspective heuristic pair and going to somebody completely outside of the field of the problem to generate a winning solution that can solve this problem that Colgate was stuck on for some time. There's some other really cool examples of this. I've got several papers written about this. If you're interested, we'll put that up on our on our readings list. But another cool example was the development of an edible polymer delivery system for drugs. And different winning solutions for this particular problem came from an aerospace physicist, a small agribusiness owner, a transdermal drug delivery specialist, and an industrial scientist. All four of these individuals took different perspectives and heuristics on the problem, and they all came up with successful solutions. So the key for us is to think about how we can rely on the crowd to help us systematically generate new, alternative, and multiple perspective heuristic pairs for our problem-solving efforts and for our commercialization efforts. Crowds have an important role in the history of technology as well. Before the invention of the modern university or the modern corporation, governments and societies relied on crowds to help solve tough technological problems faced by them. A marquee example of this comes from the UK. In 1707, part of the British fleet sank off the south coast of UK due to bad navigation and bad weather, a common occurrence in the UK, as you know. The UK Parliament, faced with this naval disaster, established the Longitude Prize in 1707, where they offered £20,000 for anybody that could come up with a working solution to finding the longitude at sea. In those days, it was very difficult to find out where you were in the world. Today, with our cell phones, we can know precisely our location because there are satellites up in the air telling us where we are. Now, the interesting thing about the prize that the British Parliament set up was that they put Sir Isaac Newton as a chair of the prize committee and a principal advisor to the Parliament on this prize. And Isaac Newton felt very strongly that the only approach to solve this problem was going to be through the methods of astronomy. Now, as you know, Isaac Newton himself was a scientific giant at that time. So when he said that the only methods that mattered are ones in astronomy, he was taking a perspective heuristic approach based on his prior experience in astronomy and applying it to this problem. Regardless of what he said, there were a ton of solutions that got offered. In fact, more than 100 were proposed. Some of them were quite creative. For example, somebody proposed that we should have telepathic dogs on ships that would bray when we cross the longitude. Other people said, all we need to do is put cannon platforms at sea that would go off at certain times that would inform the ships passing by as to where the location was going to be. Again, a very practical solution to this problem. The winning solution for this ended up coming by the invention of a clock or chronometer that could actually keep track of time. Here, John Harrison, who was an unknown carpenter in Yorkshire, came up with the winning solution because he understood expansion and contraction of materials. The problem at that time was that clocks that were being made could not keep track of time once they left shore. Once you were on the ship, because of temperature change and humidity change and the motion, clocks would very quickly lose track of time. And the solution relied on the fact that once you knew the time you left at shore and the time currently you were faced with, you could, through trigonometry, come up with a proper location of the longitude. Now, what we see here again is by going to the crowd, we can get diverse perspective and heuristic pairs that can be applied to a problem. Some may be successful, some may not be successful, but that's the whole point. Here we want to generate a variety of perspective heuristic pairs to solve our problem. Other historical examples of this include designing the dome at the cathedral in Florence. That was done by Brunelleschi, who was not an architect, but a goldsmith, and also the invention of food canning to feed Napoleon's armies, done so by a pharmacist. So throughout history, crowds have been an important way in which we can generate at scale diverse perspectives and heuristics to help us solve problems. Now you must be wondering, why is it that the crowd, a random set of people that we basically ask the world to come help solve our problems for, can outperform the most elite institutions? Our lab has been working on this problem, trying to understand and unpack why is it that the crowd can beat solutions from as far back in history as Isaac Newton to now Harvard scientists or Broad scientists or scientists at other elite institutions like NASA. And what we have come up with is a fairly simple explanation. Many of you may recall in statistics that your professor talked about the fact that you can represent any activity through a statistical distribution. For example, the normal distribution, the Gaussian distribution, or the bell curve distribution. They're all describing the same thing, where basically the outcomes you're getting from a particular process follows a probability distribution that looks like a bell curve. Now, when you do something once, what statistics will tell you is that the first time you do something independently, you will get a statistical distribution, which is going to give you the average value. Over time, as multiple people start to do the same activity independently, you will see the entire distribution shape up. Now, what the crowd allows us to do is it allows us to see the entire distribution of results. We see the bad and the ugly. So think back to cannons at sea, as well as braying dogs that had telepathy, all the way to a great extreme value solution on the right side of the distribution from what came about from the chronometer, from John Harrison, to the examples that we've talked about so far in modern times. So what the crowd allows us to do is to come up with the entire distribution, and then as people sponsor the crowd, we can pick the best ones, the tail parts of the distribution. And often this tail part of the distribution is way better than what even the elite institutions do. The elite institutions end up being the average because they're just taking it one crack at the problem, versus the crowd gives us the entire distribution, and then we pick up the tail part, the extreme value part of the answer. We can now put the crowd approach to generate multiple perspectives and heuristics within a broader innovation framework. Within innovation studies, there's been a consensus among scholars and practitioners that what matters for innovation are increased amount of ideas and the variety of ideas. And of course, the crowd will give us both of those. And so the crowd can help us generate those ideas. But innovation also requires selection. Not only do you want lots of ideas and lots of different ideas, you want to actually be able to select amongst those. And the one way to envision an innovation process in a company is to think about it as a funnel. The front end of the funnel has lots of ideas flowing in that we can use the crowd to generate. And then there are various selection gates that help us pick amongst the most promising ideas and then push them through the development process till they hit the consumers and our customers. So generation and selection are actually two very important activities that drive the innovation process forward. And we can take this idea of generation and selection and then apply them within a framework of a 2x2. The 2x2 has two dimensions. On the bottom axis, we have idea generation knowledge distribution. Here, what we mean by this are the perspective heuristic pairs that we need to solve our problem. Is it narrowly distributed? Are they actually sitting within one person, one team, or one company? Or are they broadly distributed in the world? The second axis, the vertical axis in the 2x2, is the selection knowledge. Where do the perspectives and heuristics on what to select amongst all the ideas that are being generated? Is that concentrated in one person, one team, one genius inside of a company, or is it broadly distributed in the economy, in the marketplace, etc.? And the 2x2 then helps us now start thinking about how to position the use of crowds to solve a variety of innovation problems that we might be faced with. The first quadrant in our 2x2 is the bottom left one. Here, the perspective is that very few people, individuals or teams or companies, have the idea generation knowledge. They can, within themselves, be really good at creating the perspectives and heuristics to come up with solutions, and similarly can in fact select amongst them within the company itself. And this quadrant at the bottom left defines internal R&D. When we have internal R&D at companies like IBM or Google or Facebook, their belief is that within these companies are enough teams who can generate their own perspectives and heuristics and can select amongst them, that they don't need to go to the outside world for help. But as we've seen, the outside world can be a great source of perspectives and heuristics for both selection knowledge and generation knowledge, of course. Now, the use of contests is a way to think about a world in which we can rely on people from around the globe to help us in generating new perspectives and heuristics to come up with solutions. So lots of people come through and have broad knowledge distribution for a problem to come up with potential solutions. And then a few people inside the company know how to select amongst them. And that puts us in the bottom right quadrant. The top left quadrant is one where we anticipate that a few people can come up with the great ideas, but lots of people can help select them and in fact can help improve them. This model of a consortium has been widely used in the development of the technologies of the internet. The Worldwide Consortium was set up as a way where a few people would have great ideas of protocols, and then the whole world would get engaged in improving on those protocols and help select those protocols and standardize those protocols over time. Finally, the top right part of the quadrant of the 2x2 gives us a quadrant where we can be a fully crowd-enabled model. Here, the crowd helps us generate all the ideas and also helps us select amongst those ideas. A clear example of this is the Linux and open source movements, where lots of people in the world collaborate together to build on each other's knowledge and share those ideas and then select the best software being produced. But even in commercial enterprises, we now see the use of full-on crowds. My favorite company in this is Threadless, where Threadless enables the world to submit ideas for the graphics you want on the t-shirts. So many different perspectives and heuristics are being generated for the graphics, and then their whole community helps vote on them and select them and come up with the great answers that they then print for their customers. And so this is a great example of a company that makes physical products this way, but also the app stores that we now see proliferate in the smartphone marketplace. The app store is really a view that says the perspectives and heuristics needed to generate great apps is widely distributed in the world. Anybody can have a great idea of the app. And then also, the market determines what wins and what gets selected, not one person inside of a company deciding what the best answer is. So this framework helps us as entrepreneurs, as commercializers, as innovators, to be open-minded about the use of the crowd to generate for us perspectives and heuristics, both for coming up with new ideas, but also in selecting those ideas to bring to marketplace.
And I came to MIT Media Lab, and a couple of things struck me. First of all, the Media Lab has a very close relationship with industry. So twice a year, we would invite all of our industry sponsors to what we call Demo or Die. And it was an event where, it was a week-long event where we had to show our technology. Like, you couldn't just show PowerPoint. That was not good enough. You had to show actual prototypes of what you were building. And so for a number of years, twice a year, we'd have this demo or die, sponsor week or demo or die week. And we'd show our work. And at the time, the technology I was working on was basically building devices that could help individuals on the autism spectrum interact with each other better. But then we have all these companies who wanted to use it for other applications. So for instance, Toyota wanted to use it to monitor drivers who were distracted or asleep. Bank of America wanted to understand the user experience and make it better. PepsiCo wanted to use the technology to do product testing. And I kept a logbook of all the different use cases. And when we got to about 20 of these, we were basically ignoring these sponsors because we had no mechanism of licensing our technology to these companies. So Ross Picard, who was the MIT professor I was working with, and myself, we went into the Media Lab director's office and we said, you know what, we need 10 more research students because this is no good. We're upsetting our sponsors. And he said, this is not a research challenge anymore. This is a commercialization opportunity. And I had this knee-jerk reaction. I was like, no, you're messing up with my career plans. I want to be faculty. Like it never crossed my mind that I would start a company. But then I thought about it and I felt that I had this unique opportunity to take something that I've worked on in academia, that I was very passionate about, and then bring it to the world in a very scalable way. To me, that was the tipping point. In academia, you're always pushing the state of the art, you're always pushing the envelope, but you don't often have the chance to apply something you've built at scale and really change how people either do business or communicate with each other on a day-to-day basis. And so that was the impetus for starting Affectiva.
Now let's apply the business architecture framework of value creation, value capture for a business model, and the operating model, the structure, capabilities, and assets you have to a fun example. One of the privileges of being a professor is that I get to travel around the world to meet with various companies, to give talks at various universities, and to write cases on exotic companies around the world. And I get to travel some of the best places in the world. I've been to Istanbul, I've been to Kuala Lumpur, and so on. And one of my fun activities to get to know a particular culture is to participate in eating street food. I love street food of all types. So I've had, fish on the banks of the river in Istanbul. I've had, great food in Singapore, great food in Kuala Lumpur, great food in LA, Santiago, Johannesburg. It's incredible. So I've been very privileged to be able to experience culture this way. And one of my favorite street foods is Mexican tacos. I just love tacos. Nice, spicy tacos just make my day. And I've met amazing people through engaging in eating street foods in the various cities that I go to. So what I'd like us to do is to take this example of street foods and imagine creating a business architecture around street foods, and in particular on tacos. So let's imagine one day you woke up and you have now inherited a taco truck. And your family is saying, hey, let's go create a business architecture around a taco truck. So what I'd like you to do first is to think about value creation. What are all the ways in which you will create value that will drive customers to come and transact with you for a taco truck? As you've noticed, I am a big believer in crowds. I study crowds. I get crowds engaged in a lot of interesting problem solving. So for this particular challenge, I went to my lab and the crowd in my lab, and I said, hey, lab mates, help me out at coming up with various value creation options for a taco truck. Here's what my lab mates came up with. It's a lot of fun. So the first one they said is, well, you could have a Mexican taco, but you could also do differentiation based on fusion tacos. You could have Tex-Mex tacos, you could have Greek-Mex tacos, you could have Korean-Mex tacos, all these different ways in which you could create differentiation for tacos. You could also differentiate based on the variety of drinks you have and the variety of sides you have. So that was one aspect of differentiation. Other people said, why don't you start a white glove service for tacos? So when you come into the taco truck, it's not just a taco truck, it could be taco bus. And there's a maitre d' there, there's fine tequila there for you, fine wine for you, fine drinks for you, right? And there'll be tableside service for tacos. Some people may go for that. Additionally, you could imagine that you are not only just going to provide tacos, but you're going to provide the entire cultural experience of being in Mexico. So mariachi band, the crazy wrestlers, you name it, you'll get to experience that as part of the taco truck that you come up with. You could even go further. You could say, well, not only are people coming to me for the tacos, but they may have some interest in Mexico, so why don't I offer trip advice and tips to do things in Mexico? Or you could even build a direct network effect business from this, where you attract people that love tacos and want to meet other people that love tacos, and then you can then create a whole lot of value for all the taco lovers in a particular city. So as you can see, just a little bit of creativity around value creation opens up a range of optionality for you for a simple taco truck. Now let's apply this same perspective on value capture. So the first thing you can do for a taco is you can make sure that you price it in a way so that you make up for your costs. So you charge price greater than the cost you have, and you can charge per taco to your customers. You could also imagine a subscription service for tacos where you charge dollars per month, and then you can have an all-you-can-eat option, or you could limit the number of tacos per month that a customer can get access to by having a subscription service. You could do a freemium model, kind of like what, Spotify does. You can listen to music for free, or you can pay extra money and get more personalized recommendations from Spotify. In this case, you can imagine, you say, my freemium model is I'm going to offer tortilla and beans for free, right? But the sauce, the extra ingredients like meat and fish and vegetables will be extra charges. Me, I would definitely pay extra for the jalapenos because I love spicy tacos. Finally, you can imagine a very different value capture strategy, which is you could convince the Mexican tourism authorities or the various city or regional-based tourism authorities to sponsor free tacos in return for advertising, right? You could say to them that I will attract potential tourists who want to go to your particular town, your particular region, your particular activity, your particular resort in return for giving them free tacos. You will make money on the advertising, customers will show up for free tacos, and then these customers will eventually end up going to Mexico for tourism. Again, lots of creativity in thinking through value capture strategies for a taco truck. Now let's focus on the operating model for the taco truck enterprise you're going to build. Recall, the operating model has three elements: the structure, the capabilities, and assets. So my lab mates were equally as creative with the operating model as they were with the business model. For structure, they came up with the ideas of, well, let's start with a single truck business. You have a single truck and you move from location to location. Others said, why don't you start a franchise business? Make it such that you can franchise your concepts, Kareem's Amazing Tacos, to different other business owners that they can then deliver the service to for their customers. Others said, there's a farm to table movement, so why don't we start a farm to truck movement where you are a fully vertically integrated business. You own the farms, you own the processing of the ingredients, you own the trucks, and you own the employees to get the tacos in front of a particular customer. Others said, this sounds all too complicated. Let's just simplify. Why don't you actually make this into a make your own taco business where the truck shows up, you have all the ingredients sitting around, and then people can come in and make their own particular taco. Very different ways to imagine a structure for your particular enterprise. capabilities. Well, you can have a range of capabilities to enable value delivery. One might be your ability to create unique recipes for tacos. The spicy Mexican, Korean, Indian mix of a taco. That would be something amazing that you could have and that nobody else could copy. Others said, well, of course you need management experience in how to run a taco truck, both from the fleet operations to the real estate, to the location finding, to the training of employees. All of these are capabilities you need to have in order to be able to have a successful taco truck business. Finally, others said you need to think about assets. Your unique recipes are, of course, an asset. You might have a secret taco sauce that nobody else can copy, kind of like the McDonald's special sauce or the Kentucky Fried Chicken sauce or the special Coke recipe. So that's an asset you could have. You would own trucks, right? Or you might be renting trucks. So there's physical truck assets that you might be owning. And then, of course, there's all the data about how your customers prefer tacos, what time of day works best for what type of tacos, and what the different market segments and location and real estate segments want in terms of tacos. Those can be all data assets that you build and provide value delivery for your taco truck business. So what we've done here is we've taken a simple model of a fun taco truck example, and we've shown how entrepreneurs can start to be creative in their business architecture, can actually innovate on the business architecture itself, both in terms of your business model, value creation and value capture, but also on the operating model, your structure, your capabilities, and your assets. And these things come together in your ability to enter a market successfully and win. Business architectures, the business model you have, the operating model you have, can help you win in the marketplace, but also can become an Achilles heel as the market changes. A great example of this is what happened to Blockbuster in the United States when it came to video rentals. So some of you may recall Blockbuster was a company that was literally a blockbuster. On every block, there was a Blockbuster video rental store. And here was a business model that was based on charging members a fee for renting DVDs or renting VHS. And by the early 90s, Blockbuster led the US video rental market. And at its height in 2004, Blockbuster had more than 9,000 stores open worldwide. Blockbuster purchased VHS tapes and later DVDs for distribution and then rent them out for customers for 3 days. And if you were late, they charged you a late fee. In fact, Blockbuster made up to $800 million per year in late fees, 16% of their revenue. They had a very interesting business model and a very interesting operating model. However, over time, Blockbuster's business model and the operating model, its business architecture, collapsed in the face of Netflix. And so they went from a peak price in the stock market to then becoming bankrupt. And what we're going to try to understand next is how the business model and the operating model that Blockbuster had ran right aground against Netflix. How Netflix changed every aspect of video consumption's value creation, value capture, and operating model. And we'll see how you, as an entrepreneur entering the marketplace for technology, both need to think about not just your own business model and your operating model, but also the potential competitors that exist, and how either you are going to be differentiated from them or the threats you might face from your incumbents or your competitors based on the logic of your business model and your operating model. So let's dig in deeper into the Blockbuster business and understand how they were a success, and then later figure out why they ended up failing. So whenever we think about a business, we always want to first think about its business model. And as we've been discussing in the course so far, a business model for a company is a function of two main things. There is value creation, all the reasons why customers come to you and want to transact with you, and there's value capture, all the ways in which you make money from all the value you're creating for the company. And so when we think about Blockbuster, Marco, what do you think? What was the value creation that Blockbuster offered?
Don't you remember the big yellow stores in all the neighborhoods?
Yes.
The value would be created by offering all these great blockbuster hits.
So like Hollywood
in the stores.
hits, yeah.
Hollywood hits, all kinds of popular movies.
Yes.
And you would show up at the store, have a great store experience, talk to the store manager and various employees in the stores, maybe get some advice.
Yes.
On the most recent movies, and you would find right there, ready for you, a really good availability of the top, most interesting, most popular movies.
So like recommendations and curation, yeah.
It's all part of it.
Yeah.
It's all part of it.
Of the movie, of the Hollywood hits that were coming on.
Exactly.
Right. And then what was value capture? How did they make money?
They made money basically just, rental fees.
Yeah.
You would rent
per video.
Per video.
Yeah. Right?
Per video, yes. It feels strange to even say, you would actually get the DVD, you would bring it home.
I remember the
watch
VHS
it.
cassettes, yeah.
Before that, my goodness.
Yes.
Then late fees, of course.
Late fees,
yes.
yes.
I loved late fees.
Yes.
Lots of money for
I think
late
they were
fees.
making like $900 million a year on late fees. I mean, it's unbelievable.
The cost of lateness.
Yes.
Fantastic. Yes.
Yeah. And then I also remember, in the days of VHS, they would charge me extra for not rewinding the damn tape back to its beginning, right?
Another historical relic. The rewind fee.
Rewind fees.
Yeah.
Yes.
Very cool.
Yeah. And what else? How else did they make money?
Everything else that you needed, of course.
To enjoy the movie experience.
Right?
Yeah.
So the popcorn, the chocolates, all the stuff that was kind of bad for you.
Yeah, so all the snacks, right?
You show up at your great Blockbuster store, you get the movie that you wanted, and by the way, the movie had to be available, right? It was always like going home without having a movie stocked in the store, the latest Star Wars or whatever, was a real disappointment, and so stocking was a big deal.
So when you start talking about stocking, right, that's not about value creation, value capture. That's really how the company actually works, right?
That's right.
So that's the operating model that the company has.
That's right.
And so when we think about the operating model, what comes to you in terms of what Blockbuster had to do?
Well, Blockbuster was built to deliver on all these great value creation points and value capture points, right?
Yes.
So as part of this, the store, the store design, the store location, was a big deal.
So store operations.
Store operations.
Right, location.
Design. Design.
Yeah.
The HR policies, recruiting and
because you have people walking around.
And not just people, you have to have the right people.
Yeah.
You want to recruit a bunch of movie buffs to come in and help the customer choose what the customer might want. So all kinds of people running around. I think at peak they had 84,000 employees.
Wow,
like that.
wow. 84,000 employees. And so, and you were saying what would happen if the Return of the Jedi was not in the store?
So you need to actually have problem. So again, the supply chain was a big deal, right?
So logistics and supply chain.
Logistics and supply chain was a big deal for Blockbuster, making sure that the right movies were available in the right quantities, in the right locations. Pretty complicated.
So demand management, demand forecasting.
Yep. You don't want to run out of movies. You don't want to run out of popcorn.
Right, and then all the warehousing, right, to put all the movies in.
right, and take them from place to place and so on.
Everything that you need end to end.
Yeah.
To deliver.
So the operating model really has to be aligned with the business model, right? The operating model enables value creation, but also value capture.
Right. And Blockbuster was really incredibly successful in its time because of this tight alignment.
Yes, 9,000 stores,
business model.
at their peak.
Right.
So very good setup in terms of the company and what it can do. So then let's talk about Netflix, which ended up destroying these guys. And let's do the same analysis. Let's try to figure out business model and operating model for Netflix as well.
Sounds good.
So let's talk about the Netflix business model. And we're going to focus really on the business model that's sort of the 2.0 business model, the streaming business model, right? Not the DVD mail business model, but the streaming business model.
Because Netflix started, as mailing out DVDs, right? So you would go on the internet, you would pick out the movie that you wanted, and then it would be delivered to your house via the mail. Right?
So then again, let's do the same analysis, right? We're going to do value creation, like all the ways. Again, the key thing for us, whenever we're analyzing a business, is to be rigorous about separating out value creation and value capture.
Mm-hmm.
So what is value creation in the Netflix 2.0 business model?
So consumers love Netflix because it streams to them a potentially huge variety.
So streams and is on demand.
On demand.
So you don't have to go to a store, right? You can just be on your couch or on your device anywhere in the world, and Netflix will give you the content you want.
That's exactly right.
All right. Okay. Yeah. What else?
And it's a huge breadth of content. It's less about the blockbusters any particular week. It's much more about sort of getting a huge variety of different kinds of things that you might be interested in, and then also tailoring the selection process on the application, on the app, or the website to your own individual interests. So using something that is known as collaborative filtering to potentially, as you accumulate customer data in terms of what they like, you begin to make suggestions based on what similar people might have liked as well, and you start steering people towards content. So
here you would talk to like the store manager or the employees to figure out what next movie to watch beyond the hits. Here, the system is just telling you based on your own
history. Based on your own history and the history of similar people, sort of what you might like, make suggestions, displays the videos on the screen, so it's easy for you to pick them out, and essentially guiding you through the incredibly large inventory that they really have on their own back end.
So let's talk about value capture. Like, what was value capture in the case for Netflix, or is in the case of Netflix?
Value capture is real simple. It's just a monthly fee where you pay every month and you get anything that's available. So all you can eat, basically.
So subscription. And all you can eat.
All you can eat.
Right. So they're not charging me per gigabyte, right, or per reel of tape, or the number of movies I'm watching.
No rewinding.
Fees. It automatically rewinds.
No late fees.
No late fees. No snack fees.
No, it's 3 a.m. and so we don't feel like delivering it to you at this point in time. Fees.
Yeah. I mean, it would be kind of cool if they could do like 3D printing of pizza or food like them, right?
That would be fantastic. They could actually deliver that.
Yeah. I should patent that.
If you could stream pizza, that would be fantastic.
That'd be awesome. Yes.
That would be great.
But in this world, right, you're basically thinking about yourselves as very simple value capture, subscription based, right? Here you can see and imagine complexity here in terms of the right rental fees, the right late fees, the rewind fees, the snacks, and so forth. Here, simplicity in terms of value capture. So again, like we did with Blockbuster, what capabilities do you need in your company to be able to deliver on this setup? What's the operating model?
The operating model is totally different from Blockbuster, right? Totally different. So you have a small number of employees. I think at the peak, so far I think we're talking about 4,000, 5,000 employees, something like that, maybe even less. they have very different skill sets from the employees that you would have had in the Blockbuster stores.
For
We're
example?
talking about, sort of data scientists that can help interpret the data that Netflix accumulates, engineers that can code.
So software development.
Software,
Yeah.
exactly.
Yeah.
Code the apps, marketing people, people that will do the deals for the content, right?
Yeah.
Which also are based on the data, informed by the data they capture from their customers.
Yeah, here you're just waiting on the ebb and flow of Hollywood hits. Here you actually are deliberate about the content you're actually getting in.
And it's a much broader range of things that you want to make deals for. And very asset light as a model, right?
Yeah.
They don't have stores.
Yes.
In fact, they don't even have data centers. They stream from, I think, Amazon. Amazon Web Services delivers the Netflix.
So you just have to learn
content.
how to use the Amazon system, but you're not owning the data centers, right,
Exactly.
around the world.
I think they're Amazon's biggest customer.
So interesting.
Yeah.
So interesting. So you can see, like, this is even though in the end the experience is the same for the consumer, you're watching a movie at your home, the ways in which this gets delivered is so different from here versus there, between
Completely
Blockbuster
different.
and Netflix.
Completely different.
Yeah. So what do you think? Like, easy or hard for an existing company, right, like Blockbuster, to now adapt to this new operating model that is being put together? The new business model?
Super hard, right?
Yeah.
Because what happens is everything that's made you successful in the past now needs to change, right? So this great alignment that you had over the years to create this fantastic store experience, all of a sudden is completely obsolete.
Yeah.
And morphing from this kind of operating model to that kind of operating model is really hard. Again, you have different skill sets, different people, different store strategy, completely different sets of capabilities to develop,
So even though Blockbuster had the opportunity to buy Netflix early on, you can imagine the people in the late fee department saying, wait a second, there's no late fees. How are you going to make money, right? The retailer is saying, wait, our skill set in building retail stores now becomes obsolete in a world where we don't need retailers. And where are the software developers? Where are the software engineers that we need to be able to do that? So even if this becomes apparent, the challenge for most companies when they're faced with the shift is, how am I going to convert myself in this one finely tuned model here to one over there?
Operating models kind of have a life of their own, right? So they're very difficult to change.
Yes.
They require all kinds of different assets and capabilities to deliver the kinds of value that you want in the business model.
Yes.
And when they get optimized and built out over time, they will resist change. And you see this in companies like Netflix. You see it in any company that has spent many years optimizing the connection between business and operating models.
Yeah. So tough for us to do.
Emotion AI, or artificial emotional intelligence, is this notion that computers need to understand human emotions and be able to respond to it in a smart way. We actually envision that emotion AI is going to be ubiquitous. If you look at human-machine interfaces, they're quickly becoming conversational and voice-driven. They're quickly becoming perceptual, so we're starting to see the ubiquity of camera sensors and this idea of computer vision. So I believe we're a few years away from computers understanding humans in a truly fundamental way, which means that there are many, many applications of this technology. And I think for Affectiva, that's both the opportunity, that's what makes it so exciting, but it's also the challenge. From day one, from spinning out of MIT, we've always had inbound interest from a number of industries. And that, we had to take a step back and first define what are the industries we're never going to play in because they don't match our core values. But then beyond that, we had to identify, okay, which of these industries do we actually solve a real problem? And what is that pain point that we're solving? And then is this a big enough space for us to play in? And so I'll give you one particular example. A couple of years ago, we got inbound interest from a Japanese automotive company. And that was a space that we knew, was interesting to us, but we didn't play in at all. And so when this Japanese automaker approached us, we were like, that's interesting. So we took on the project as a way to explore the market and kind of fine-tune the technology so that it works in the automotive context. But in parallel, we took a very kind of thoughtful, strategic approach to identify, okay, how big is the automotive industry and how big is our play within it? Like, understanding driver safety or distraction or drowsiness or intoxication. How big is that space? And then we kind of projected to the future where it's all going to be robotaxis. And we were like, okay, what's our play within the robotaxi world? Like understanding the occupants and personalizing content to them. How big is that market? And then we quickly realized, okay, that's like a huge business opportunity. Combining that strategic approach with proof of concepts with that particular Japanese automaker allowed us to decide that we want to play in that market, and then we were able to prioritize it and build products specifically for that industry. So I think it's not always easy. There are definitely industries that I'm particularly very passionate about. But I also understand that it's important for companies to focus. And I will say, because we've been focused on the automotive industry, we've been very successful in the last couple of years, especially the last year, because we're able to, because we're immersed in that industry. We know their problems, we know the customers, we know our partners very well, and that's allowed us to be very effective. I do believe that using proof of concepts as a way to explore a market is really critical. And we've done that many, many times because it allows you to really understand what are the partner's needs, but it also identifies the main gaps in your product. So again, I'll give the automotive example. When we worked with this Japanese automaker, all of our work up to that point did not involve doing anything in the car. It was mostly on your phone, you're watching video content. And so to repurpose the technology for a car context, we were like, oh, people move their heads all the time. Like that's a challenge for the technology. Or when you're driving at night, how are we going to handle that? So we had to retrain all of our algorithms to recognize people's emotional and cognitive states using both a normal kind of camera sensor, but also a near-infrared camera sensor. And then we had to retrain the face detection algorithm to work from different angles to allow for different head movements and so on. So I think I really am a big fan of using proof of concepts to explore market opportunities and also build deep partnerships. It's the best way to find advocates that want to try, early champions of the technology, and build deep partnerships and relationships with them. We actually have a number of business models at Affectiva, and we've aligned our business models with the industry or the partners that we work closely with. So for instance, in the advertising research domain, it's a software as a service business model, and it's volume-based. You pay up front for a number of ad tests, and that gives you a volume discount, and it's a software as a service platform. It's pretty straightforward. But then when we started to do a lot more work in the automotive and robotics space, we realized that software as a service kind of rhetoric does not work. It's more of a licensing model, and it's usually licensing per unit, per car or per robot. We charge a fee per unit. And so we had to accommodate kind of that industry and the industry's needs. The other difference was in advertising, it's okay if the data runs in the cloud because it's all offline analysis, whereas in automotive and robotics, it's a real-time application. The car has to know in real time if the driver is falling asleep, and it needs to respond in real time. That's a really critical part of the application. And so we went from running everything in the cloud to running everything on device, which was a big technological challenge. And it took us, a good year and a half to figure it out. But it was very important to be able to play in that market. So I think being open to different business models is important, and testing it too. Like we play around with different combinations of things, different pricing models, and fine tune as we go.
Understand the market for your technology, product, or service. Understand what the competition is. And the status quo, by the way, is very powerful. Competition, as I mentioned earlier, it's very hard for customers, large companies, or institutions to change. So even if the new approach is better over many dimensions, it has to be significantly better. And it has to be so much better that it creates a need, not a want, but a need for the customer to change. So to understand that, not only is this better, but it's so much better, or we've transitioned to a new paradigm that is so compelling that it requires customers to buy this product or service. So understanding that, understanding not only the status quo as a competition, but what other technologies are being developed, because we have many great universities around the world, we have many great incubators, we have many brilliant people, and so understanding that you might have a great idea, but others might have great ideas too, and how your idea might compare to other great ideas that are out there. So understanding that, and as an investor, we will often see companies present to us that they have no competition, whereas we've seen 10 other companies presenting the same idea, right? And they just don't know. So it's really important to know what your competition is, to understand your market, understand what business model, if you're going to create a company, what business model will make sense, right? And if, let's say, you're inventing a new form of, battery material, the best plan might not be to manufacture your own batteries, because it would be extremely expensive to do that. So maybe you need to figure out where you plug into the existing value chain, and leverage, existing industry, and just provide, your piece of it, and which could be extremely valuable.
We now focus on accelerated innovation with better seed selection and needs identification. After all, innovation is about meeting unmet needs with compelling science and technology seeds. Our interest here is really helping innovators, entrepreneurs, improve their odds of success by making innovation processes more streamlined, more balanced, just more sensible, what we are calling accelerated innovation. We are building on the discussion of methods, perspectives, and frameworks to generate better seeds. Let's start with this question. What are the reasons more innovation projects and ventures have not succeeded or are not meeting expectations? After all, the startup success rate is estimated to be in the single digits percentage or low double digits percentage, depending on the area. Why is innovation so hard? There are a number of reasons. At its core, innovation is about effecting change, fundamental change, to current products, processes, and methods. Change is hard. Established technologies and products can be deeply entrenched in many areas. Customers may just be happy with them and not actively seeking change. In addition, incumbent companies can make it difficult for change to happen. All in all, innovation can often be received by markets and industries the same way our bodies receive and respond to foreign organisms with an antibody-driven adverse reaction. In order to succeed against these odds, new innovations must offer an order of magnitude advantage in terms of benefits, performance or convenience or ease of use or just much lower cost. It would be nice to start with compelling seeds, breakthrough discoveries that unleash totally new capabilities, like gene editing or 3D printing for that matter. However, we also need to be patient, as it takes time, sometimes decades, for technologies to mature. 3D printing, for example, was invented and developed in the late 1980s and even the early 1990s when I was a graduate student at MIT. It was exciting to see this technology crawl and walk out of the labs, but it took a long, long time, a very long process of performance improvement and cost reduction for it to become commercially ready. Initially, just the basic idea was demonstrated in one of the engineering labs at MIT, and it took nearly 2 decades of work to turn it into a commercially robust, market-ready system with a variety of applications. If you were an inventor who was interested in commercializing technology and were considering 3D printing in the late 1980s, you better have been patient, and so must your investors be. Or you should work on other more advanced or mature technology. There are several innovators who tried to create new products and ventures using the 3D printing technology, but had to fold down because they were too early. So while breakthrough technologies offer tremendous potential, they might take a lot of time and resources to realize this potential. Sometimes we get excited about a breakthrough's potential. This includes innovators and investors, not just the inventors, who then get disillusioned by the time taken for the technology to develop and mature and really bear fruits. Too much investment and energy chases breakthroughs, often to be disappointed because of the time taken for it to mature. This has happened in various areas like solar energy to battery technology and even health sciences technologies like gene therapy. The art and science of translating such technologies, moving them from lab to market to create new socially and economically beneficial products and ventures, is to know when to start working on these technological seeds and what market applications to tackle. This is what we aim to learn here. We'll discuss how to consider and how to integrate technology, market, commercial, and team characteristics. To improve the success odds of breakthrough technology-driven ventures, we must start with compelling, promising technological seeds. We quickly review a classic technology maturity framework initially developed by NASA called Technology Readiness Levels, or TRL. We also discuss adaptations to the present day and to different industries going beyond the defense industry. So while the detailed and specific application of this framework may vary across industries, the general thought process of understanding and discerning technology maturity and readiness is actually quite powerful. Let's consider the process of translating and commercializing a breakthrough technology. The technology might be sourced from your own venture or R&D labs, or from a university or government R&D lab that you have close access to. Most research universities and defense research labs have a technology licensing office that you could visit in person or on the web, which lists a large number of inventions that they want to commercialize. Universities like Harvard or MIT, Stanford, and the University of California invest significant resources, billions of dollars in research, and produce patented breakthrough discoveries, which they are eager to turn into socially and economically beneficial products and ventures. The defense research labs in general and the Air Force research labs in particular are a good source of technological seeds. They're usually a treasure house of technological seeds, in fact. In addition, they may also support small businesses interested in commercializing their technologies by offering technical guidance and sometimes even funding in the form of Small Business Innovation Research grants or SBIR grants. As you may remember, the ubiquitous GPS started as a military technology commercialized by private sector companies, which have now put them in wearable devices and some years ago in smartphones. Similarly, the roots of the LASIK corrective eye surgery can be traced directly back to the Air Force Small Business Innovation Research Program. So these programs are definitely worth considering. University and defense research labs and technology licensing offices are good sources of new technologies. But innovators also need to develop the ability to assess, kick the tires, and select the right technologies, which are a good fit for them. Often, you, the innovator, individual or team or a venture, are passionate about a certain area, like clean energy or healthcare. Your firm organization might have strategic thrusts as well. This gives a reasonable starting point and what kind of technologies you would consider. Yet, the selection of technologies to source from research labs can be very daunting. The search has been likened to finding that proverbial needle in the haystack. Luckily, improved search technologies and efforts by these research labs to better describe these technologies is helping this search, but it still takes work. The innovator needs to understand the technology, its benefits, and most importantly, its maturity or readiness. Here is where the technology readiness level framework, originally developed by NASA, can come handy.
In this module, we will learn about how you can get systematic feedback and validation for the concepts you have developed. In the earlier parts of the course, you have already generated potential use cases for the technologies and the matching business architecture concepts. There are many hypotheses that are built into your concepts, and now we need to go out there and think about this systematically and comprehensively. Previously, we introduced you to the Cloverleaf model to provide you with a framework on how to evaluate the various aspects of your business. The key thing here is to have a framework for evaluation. Cloverleaf provides you with one framework for evaluation, but depending upon the technology you may have and the business you have and the business concepts you have, you may choose to develop your own framework or borrow from somebody else. It can be different for each business, but the critical thing is to have a framework towards evaluation and feedback. The way you get to assess your business is to ask questions. You have to go out there and ask questions of yourself and your team and the knowledge base you already have about your business concepts. And even more importantly, you need to go outside. You need to go outside and talk to customers, to potential suppliers, to potential manufacturers, and get them to also test and validate your assumptions and your hypotheses that are built into your use concept as well as your business architecture. Again, the Cloverleaf framework can provide you with a set of questions you want to go after. As you think about the Cloverleaf framework, look through the questions you have asked yourself convincingly and those where you think you want to go and get more information and more validation. Or you may have your own framework and you may choose again to see where are the open question marks for yourself that need to be dug deeper. We have offered a range of resources in the course on various techniques to interview effectively. The bottom line is that you have to get out there and start interviewing people. The goal of interviewing is to get you close to the market. You don't want to spend time and resources in developing something that no one wants. Interviews are an effective way to get the maximum amount of information for the minimum amount of resources that you have sunk.
Another mistake a lot of startups make, especially early on, is the presumption that the first thing they need to do is raise money. And that almost invariably is not the first thing a startup needs to do. The first things they need to do are take whatever idea they've got and get it in front of as many people as possible that are not their grandma or their friends, right? Because you tell your friends or your grandma what you're thinking about doing, and they're going to want to support you, and they're going to want to tell you your idea is good. But strangers will be much more honest, and people in the industry that you're thinking about working with, they'll be much more honest, and people that don't have time to invest in you will be much more honest. So before you try to go out and raise a bunch of money, really having something of substance that you can move forward. And then prototype, right? One of the mistakes I see people making is they feel like they need to fully bake everything before they go show it to people. So they're in stealth mode for 6 months or a year. Huge mistake. Always be thinking about, there's a phrase in startup land, MVP, minimum viable product. And whether or not you take that idea too seriously, at all times, having some sort of benchmark or milestone or goal where I'm trying to produce something that I can show people that I can then iterate on. And until you've iterated on that thing many, many times, you're almost certainly not ready to go take it to market. And if you're not ready to take it to market, you're not ready to raise money. People have great ideas all the time. The limiting factor in innovation is not good ideas. It's people willing to put in the time to execute that idea. So the people that say, I don't want to talk about my startup idea, I don't want people to steal it, that's just not going to happen. You should tell everybody about your idea. And one of the reasons you should tell everybody about your idea is because you have no idea what other people know about the thing that you're working on, and you have no idea who other people know. So you tell your Aunt Sally, oh, I've got this idea in this widget space or with some chemical product or this social innovation, and you don't know that her college roommate is the CEO of some other company. So telling as many people about your thing as possible allows you to start to access those networks of people that can contribute to whatever it is that you're working on. Interestingly as well, one of the groups that has lower survivability rates are people that have come from industry and they're starting some startup that circles back into that industry. They think they have some particular knowledge about a problem space, and they say, now I'm going to go start a startup to tackle that problem. Those people as well often don't access mentor and expert networks as much, and because they are overconfident in their understanding of the market that they're dealing with, don't end up being as successful. Minimum viable product, it can be as simple as a piece of paper, explaining what your thing is, drawings of it, and it's not limited to people producing widgets. or consumer goods that are being put into the market. Even if you're doing a social innovation where you're trying to, fix toilets in India, anything that you can produce in simple form, that you can show people, that you can get people to comment on, something that you can start to iterate, just something that can help manifest a visual explanation of what your idea is. So in the case of my company, I partnered with a bunch of architects and was able to produce a visual rendering of what an innovation hub looked like. And those little visual cues just help people latch on to what the idea is you're trying to bring to bear, and will allow people to access it in more direct ways. But the important thing there is something that can be iterated upon, because the importance of iteration is that it both provides the market with an understanding of what you're doing, but then it also gives you a vehicle for thinking about how am I improving on this and how is it being communicated and explained to people in a way that makes sense. Techies, technologists, coders, they're a bit like artists. In some ways, they build out this thing and it is actually a creative expression of their own work. So the more you can encourage those people to get their thing in the hands of others and get really unfiltered feedback on whether or not this is useful. One thing that helps a lot is, whether it's for techies or anything else, as you hand people your MVP or your product or whatever it is, have them just start speaking out loud as they are interacting with whatever your thing is, and really pay attention to that stream of consciousness, and do that with multiple different people, different types of people, different ages of people, because that will give you some insight into the mindset of how people are thinking about what it is that your thing is. And at a fundamental level, people want things that solve their problems. People want their pain points, their fundamental pain points, to be fixed. And those are the things people are willing to pay for. Those are the things people are willing to invest their time in, which a lot of times people misunderstand. Even a poster hanging on a wall, that is offering you something, but it's also a cost. It's a mental cost to go read this thing. It is a time cost because you're busy, you're running from one place to the other. And being able to design for convenience is something that the creator, whether it's a coder or an artist or a founder, they have to move from a place of, this is in some ways a representation of myself, and this is a thing that I am passionate about, to being something that is very outward focused. I'm thinking about other people. Fundamentally, startup life is very much an exercise in empathy. It's very much an exercise in putting yourself in the shoes and the mindset of others, because you're not merely trying to solve a problem that you have. That might be a really great way to find a problem to solve. If you say, oh, there's this thing I deal with, and every day, man, somebody should solve this. And then so I'm going to solve this. I think other people would want that. But it's that last step, but other people would want that. That's the difference between something that is just your own solving a problem, or actually creating a startup or a product or a solution that is going to help other people in the real world.
Again, one of the really important things in our business is networking, or what I like to think of my job is connectivity. How do I connect the dots between the experts in the field and the entrepreneurs and how we make decisions? How do we get the best information to make decisions? And we've developed a very strong relationship with our customers, that is the major pharmaceutical companies. And we have the ability to actually converse with them early on when we're starting these companies. And it's not about, will you buy this? It's about, we are looking at this really new technology in this particular disease. What would you like to see, or what would patients like to see to understand that this could be a real new innovative approach to disease mitigation? So we get that input, and that's really sort of on the end user, what data we should be looking at or what approach we should take to studying this new technology. That's critical. And beyond that, we leverage our own internal resources of, as I said earlier, the portfolio and other scientists, because we're also trying to develop that map, if you will, of de-risking experiments. So the market side is really the customers who are ultimately the big pharma for the major diseases. Of course, a lot of our companies with orphan diseases could actually market their own products. And in those cases, very often we'll go to the advocacy groups or the foundations that are centered around these orphan diseases, because they have a wealth of knowledge that they've been accumulating not only from the research that's done in the field, but from the patients that have those particular diseases. Feedback, I always say, is a gift, but what do you do with that gift? So if you're getting a lot of gifts from multiple different people and those gifts don't look like the same gift in terms of feedback on your particular idea or your particular issue that you're working on, it can be a very hard problem. But first of all, you have to trust certain people in the end, and you also have to trust your instinct. Now, in saying that, there are many times when we've been wrong. You know, we've turned down investments, or we've invested in things, and both sides of it, we've been wrong. But you have to make sure that you're triangulating and getting different views. You know, no one in this business is smart enough to do this alone. So, you know, soliciting feedback, views from different orthogonal sources is what we try to do. You know, people at different ends of the spectrum of, in our case, you know, developing therapeutics is very important. And then in the end, you know, it is really intuition in the end that may make the best decision, hopefully, for what you're trying to do.
So the accelerator is broken up into 3 segments. It takes place over the course of 12 weeks. So basically, each month is a different area of focus. And month 1 is focused all about really understanding what product market fit means. Talking to customers. We want every single one of our startups to talk to at least 100 customers and knock out 100 customer interviews, because that's what it takes to really know, hey, is this idea that I have, is this something that somebody will exchange money for? Is this something that's a business? Is this something that's a hobby? Is this something as a dream? What is my business? And the only way you really understand your business is within the context of customers. That's why it's so important to talk to those 100 customers. As a part of understanding that, we want to make it clear to founders that the way that you interact with customers, the way that you interact with potential funders, the way that you interact with other business partners, each of those is a separate technique. Each of those requires different skills and different ways of approaching the situation. So we have an event that we call Mentor Office Hours. It takes place over 2 to 3 weeks, and it is a very intensive experience. From 9 to 5, sometimes further than that, we introduce these entrepreneurs to each of these categories of individuals: corporate VCs, institutional VCs, angel investors, entrepreneurs, former CTOs. Sometimes they're professors that are focused on their particular engineering discipline. In the case of our accelerator, government stakeholders from throughout the DoD as well as other government agencies. And the key lesson to take away from that is knowing how you communicate effectively and how you communicate the value proposition of your business to each of those individual stakeholders, because it's very, very different. And how do you do that within the span of 30 minutes, again and again and again? Because it can be very easy to fall into pattern recognition in a negative way when you do this, trying to communicate to people the same way every single time. And that is not what will lead to the success of their enterprise. What will lead to the success of their enterprise is listening, understanding who you're speaking with, understanding what their needs are, building that rapport, generating that empathy, and really knowing, is this the right fit? Where does this person fit within the overall ecosystem of what we are trying to accomplish as a business? As a part of that, what a lot of founders find is that they may be talking to a VC that walks in and then they give their pitch and they're like, I don't get it. I don't know why anyone would want to buy this. I kind of think you might want to start from scratch. You might want to go back to the drawing board. I don't know about the dynamic between you all as founders. I'm not quite sure if that's the right fit. And then, as you can imagine, after 25 minutes of talking to a VC telling you all this stuff, you might be like, oh, well, great, that's awesome. So, you start to doubt yourself a little bit. You start to not necessarily know, is this the right thing for me? Then you switch gears, you talk to an angel investor. I love this. This is awesome. The world really needs this. This is absolutely fantastic. Tell me what I can do to help make you successful. Now you feel great. Now you talk to a customer. It's like, so how much are you charging for this? Yeah, I don't know how much you're making off margin, but that really just we wouldn't be able to buy this. It seems like an interesting idea. I just don't know if we can take the risk. You have now gone from low to high to low within the span of an hour and 30 minutes. Now this takes place repeatedly, every single day over the course of 2 weeks. And to any founder, any entrepreneur, this is your baby. This is what you care about. This is what you've spent. You've spent so much time building this out that to go through this emotional roller coaster can be very challenging. And that's the real lesson that we want people to take away from this. Being able to accept that cognitive dissonance and emotional dissonance of going from those highs to the lows to the highs in terms of how others perceive your business and how you operate, being able to look that cognitive dissonance in the eye. I think that founders who are able to do that are the ones who are going to be the most successful. They can take that and not necessarily see it as something that's an existential threat or opportunity to their business, but data points that will help them figure out what the right thing is to do. That's the main lesson that we want entrepreneurs to take out of month one. For month two, they'll have completed these 100 customer interviews. They'll have taken the time to build relationships with all these angel investors and VCs and potential customers. And now they can take that information and act on it. Now they can start to figure out, okay, so knowing that, how do I develop a product roadmap? If I already have a product roadmap, what direction do I want to take with it now that I have this additional information? How do we want to represent ourselves? How do we want to represent our brand? It's everything from marketing and branding and that side to a little bit more of the practical side for the CTO types. In our case, we're looking at design for manufacturing. We're looking at how to help them build out their supply chain, how to do logistics planning, that sort of thing. On the other side, we also work with those founders who now have capital to maybe start doing their first hires or to start building out their teams to show them, okay, so this is how you hire. This is ways that you can use to vet and interview people who are the right leaders, because at this stage, everybody that you hire is a leader. Whether they realize that and you realize that is something else completely, but everybody that you're hiring at this early stage is a seed for the culture that your company will become. So you're not just hiring a hammer to hit a nail. You're hiring somebody who is going to be a future leader in your organization, even if you see them as an individual contributor. So those are the main lessons that we want people to take out of month two. You're consolidating all this information that you got, but now you're learning how to execute on it in a way that's going to make your business successful. Month three is all about how to communicate your business to a wider audience. It's all about how you pitch to VCs, to angel investors, how you get out there in front of everybody and you be the face of your brand. and you be the face of your business. It's all about how you put yourself in front of everybody and represent your business as a leader. That's everything from executive communication and executive presentation to how to effectively convey your value proposition in one-on-one meetings. Everything there is geared towards preparing you towards Demo Day. Demo Day is the culminating event in Techstars, where we bring in everybody that you talk to, plus a whole lot more, to a large event where you are pitching in front of millions and millions of dollars worth of capital, as well as potential customers that may be worth more. And it's very much like a show. It's very much a community event. But we need CEOs to be developed into the folks who can stand in front of a stage and be who they need to be for that show.
Let's consider a breakthrough technological innovation in the energy industry, specifically in the solar or clean energy space, something I was fortunate to be associated with many years ago as an advisor. It was a company that was started by some inventors in the solar industry jointly with one of my past students. The company is called HelioVolt, and HelioVolt had an innovation based on what's called thin film solar technology. So they use a specific type of material called CIGS, or copper indium gallium selenide. Thin film solar offered significant cost advantages over more traditional silicon-based solar, but it also had lower efficiencies. So the charge in front of HelioVolt was how to keep improving the efficiency of thin film solar without losing the significant cost advantage associated with it compared to silicon-based solar. So HelioVolt was a company that was started at the beginning of the 21st century by a fellow named B.J. Stanbury, who had significant background over a 20-30 year period, starting at Boeing, where many of the thin film solar technology had been invented in the 80s and 90s. And HelioVolt now aspired to bring it to market. And the case example that we are considering here looks at challenges in bringing about a breakthrough like this to market. First of all, the significant investments that are needed to make a technology like thin film solar really viable, especially improve its efficiency. And it takes years of research and development for getting even marginal improvements in efficiency. It's a long road ahead. And that's what makes solar forever the technology of the future. Because we all think solar could be such a big improvement over existing coal-based technologies, but it takes a lot of work to improve its efficiency and to make it economically viable. The other factors to consider in this case is not just the technology readiness, but also the management and team readiness, getting the right team in place, because this is not just about improving the technology in the lab setting, but also being able to improve it in the production setting, really able to get products out at a much lower cost in volume manufacturing. And that's not a trivial challenge. Finally, you have to look at the market and competitive landscape, where you as thin film solar are not only being compared against silicon-based solar, but also the larger landscape of wind and even coal plus natural gas-based technologies. And there are countries and societies that have significant investments in these areas, and they're going to back those technologies very, very intensively. And do we have the ability to compete against them? The Cloverleaf is a framework for you to consider when you look at HelioVolt as a technology to evaluate. You should also ask yourself, are there other factors to consider that are missing in the Cloverleaf model? It's definitely a great exercise in figuring out how a breakthrough scientific and technological invention tries to get into the market and a number of challenges that it faces in doing so. The heliovolt case provides a vivid example of both the opportunities and challenges associated with translating, commercializing breakthrough technological innovation. To begin with, there were some things that were going for them. They had deep domain expertise. The founder had significant years of experience in this area and was very motivated to translate this, turn it into useful product and service. Because of this, they won some awards like the prestigious Wall Street Journal Technology of the Year Award, and they also attracted significant investment. So these were all tailwinds that went for them. But we also see in this case the long road in improving efficiency in a space like clean energy, and the tendency for the technical team to underestimate the challenges. We have this term called planning fallacy, in our research literature, which is the tendency for people who are involved in any kind of work to grossly underestimate the challenges that lay ahead. And this might be at work in this particular case as well. We also see some issues associated with commercial readiness. The technology not only has to compete against silicon-based solar, it also has to stack up well against other technologies like wind-based clean energy and even more classical technologies like coal or natural gas-based energy technologies, which have significant vested interests backing them. So it's not a trivial thing to compete against these technologies. This is one of the reasons translating such a technology takes a long time. And in our accelerated innovation approach, we want to think that if you balance the supply and demand side, if you have a less lopsided approach, you could have greater odds of success. In the heliovolt case, they probably got the supply side going, but they didn't look at the demand side so sharply. And if they had brought them together more cleanly, they may have had a better, more faster approach to bringing it to market. Hindsight is, of course, 2020. And when you're really bringing these technologies to market, there are so many factors at work that you have to bring all these moving parts together. That's what makes this both a challenging and ultimately rewarding exercise.
I see this a little bit similar to job interviewing, where a lot of folks go into a job interview and they say to themselves, I just want the job, I just want the job, I just want the job. I'll say what I need to do to get the job, because that's the position that they're in where they need that job to pay their rent, to continue on with what they're doing in life. There are other folks who approach job interviews in terms of like, you are interviewing me and I'm interviewing you, and I'm trying to get a sense of whether this is the right fit for both of us or not. The folks who are approaching the interview from the perspective of whether it's the right fit for both of them are the ones who will have probably the best experience out of the organizations that they intend to commit to. The same is true for investment. If you know that the investor that you're working with is not just a piggy bank, but somebody who's going to have your back, that's an investor you want. If that investor is a piggy bank, then they might not be willing to pick up the phone and help you when you really need it. They may have demands that you do not understand because you don't necessarily understand how they're motivated if they're just a piggy bank. Don't get me wrong, there's times when you need to open the piggy bank, and when you need to do that, you need to do that. But if you are raising money just for the sake of raising money, then you might want to take a step back and understand that you are establishing a relationship with whoever you are taking money from, and that can go a positive way or that can go a negative way. A good startup pitch is the right message targeted to the right individual. In any form of communication, there's the sender and the receiver. The right startup pitch for one person is the completely wrong startup pitch for another person. And while we do emphasize, you want to have that ability to engage in the elevator pitch and really rapidly talk about what your value proposition is and what you want to talk about, the purpose of a pitch is not to immediately make a sale. The purpose of the pitch is to determine whether there can even be a relationship. And if you go into every single pitch thinking that you're going to make a sale right there, that you're going to get a check written, you're setting yourself up for a lot of disappointment. If you go into pitching expecting, I want to get to know this person, I want to understand them, and I want to identify ways that we can work together for mutual interest, that's a winning pitch. It's very important for a founder to understand that money is not just a number that indicates how long your business can survive. It is not just a runway. Money is a tool. And you need to know when you're approaching and getting money what the purpose is that you're going to use that tool for. If you approach money in terms of, I'm going to use this to go to the bar and talk about how much money I've raised, that is not a good reason for raising money. Maybe it's a good reason for impressing people there, but it's not going to be a good reason for you to necessarily employ that money in support of your business. There's a couple of different pieces to that. First, there's having a plan for the money in terms of how you want to spend it or how you don't want to spend it in the case of like you're maybe taking on risk and you want to know that you have some sort of a buffer. There's also the money aspect in terms of where you're receiving the money from and how it's going to affect your relationship with the people that you are taking that money from. I see this a lot in terms of people investing or people accepting money for their company in return for equity, but not necessarily understanding that if you give this person a board seat, they will have a direction on the way they want to take your business. All entrepreneurs, to some degree, do not like having a boss. That's part of what makes them entrepreneurs. That being said, you will always have a boss. And the longer that you can keep that boss your customer and not somebody who's in between you and your customer, the happier as an entrepreneur you'll be.
Now that you've found the need for your seed and have got your business architecture concepts validated, you now need to pursue a path of taking your solution to the market. The big part now is for you to figure out how you're going to finance your venture itself. You may choose to raise money with a venture capitalist, a seed fund, or some angels, or you may choose to do it yourself through bootstrapping it. Maybe you might run a Kickstarter or an Indiegogo campaign, or you might decide to line up customers ahead of time who want to fund the development of your solution. Depending on the technology you have, in some cases, like in software, it's very easy to bootstrap, evaluate your proof of concept, and launch the product. In other cases, where there's deep technology ventures are present, you need a lot of capital and R&D to be done before you hit the market, you might choose to get venture capital funding or somewhere in between. Regardless of the choices you make, you have to think through systematically about the impact of this capital on your business, how you raise this capital, and the items you need to be careful about, how you actually even pitch your ideas to investors. Professor Ramananda, a colleague of mine at the Harvard Business School and an expert in entrepreneurial finance, is going to walk us through these issues. Ramna is a world expert on this topic, and I'm pleased to let you know that he's also a friend of mine. We went to graduate school together at MIT, and he has really developed a lot of insights here, and I'm grateful that he's going to join us in this course to walk us through these topics.
This actually ties very nicely to the question of how much capital do I need to build this business. So one of the things that we get students to think a lot about is the moment in the life of a company when it gets to being cash flow positive. Okay? And what that means is that the company is generating enough cash flow from its own operations that it doesn't need any external finance. Not every business can be cash flow positive from the start, right? In the example that I gave you, that lemonade stand was cash flow positive from the very first day because of the subscription model. But most businesses are not going to be that way. But we still have this ambition of kind of thinking about, can we get to cash flow positive as quickly and with as little external finance as possible? And so we want to be thinking very carefully about how much cash we burn in the early days before we get to being cash flow positive. And so to that end, we think about what are the ways in which we can learn about the future potential of this business? And can we do that as quickly and as cheaply as possible? And can we run discriminating experiments? Can we try to understand what is the likelihood of this idea working, and what is the likelihood of customers being willing to pay the amounts that we expect them to pay? And how can we learn along the way by doing some of these tests with customers to understand that? And so typically the way it works is very early in the life of technology, we might not even know if the technology works. This could be as early as sort of a science experiment where it's still in the lab. But then once we get out of the lab, we want to be able to see that it can actually work in the world. And many times I think scientists and engineers underestimate the messiness of the real world and how hard it is to take something that works in this perfectly controlled lab environment and get it to work outside. And so a lot of, particularly in tough tech and science-based ventures, the earliest stages of capital are really towards trying to understand that this technology works outside the lab. What are the parameters? What are the sort of the edge cases? What are the boundary conditions around which this thing will break down? Once we know that the technology itself has promise, we can then begin to try to understand whether there is a use case for this and whether there is product market fit. And in some sense, it's sort of, the analogy that you could use is like, does the dog food actually is there any sort of interesting new dog food? And then does one dog want to try to eat the dog food? And then the third question you want to ask is, will the dog pay for the dog food? And then once we can figure out that we're profitable, then we can take this and scale it up, right? And so there are these discrete stages where we want to understand whether the technology works. We then want to see whether there is a product market fit. Are people actually interested in using this technology? And are they willing to pay for it? The third stage is to try to understand, as this company is being built up, does it have properties that will allow the unit economics to actually be high enough that this will be a profitable business that will generate cash flow? So are they scale economies? Of course, the initial few customers will probably not be profitable because we have a lot of cost that will scale across lots and lots and lots of customers. And so initially these will be unprofitable customers, but the question is, can we see our way through to them being profitable? And once we can demonstrate that, then we raise a large amount of capital to just scale this up. And so those are sort of some of the stages that we have. And of course, between B2B and B2C businesses, the timing, the amount of learning, and the various cash flow characteristics can be very different. With consumer businesses, there is a lot of focus on virality, right? Is it the case that these customers, once there is, how quickly are customers individuals referring this to their other friends? How much does it cost us to acquire a new customer? Do we have to do a lot of advertising, or are people just telling their buddies about it? Are they network effects? Those end up being very, very useful properties of consumer businesses. The reason for that is that if this business has network effects, it's called a sticky business. Why is that the case? Because if my friends are on this platform, I'm more likely to join the platform. I'm less likely to leave the platform. And so businesses often look at these metrics around churn rates and stickiness, and businesses that have, investors look at metrics such as churn rates and stickiness, and so businesses that have these kinds of properties end up being very valuable. Another property that people look for in businesses is, does it have scale economies? Because what that means is that once you can sell this product to a customer, the when you scale it up, these fixed costs can be amortized across a large number of customers, which then make this a very profitable business. And so as we think about the drivers of cash flow, obviously profitability is one big element of it. And then asset intensity is the next big element of it. And asset intensity really has to do with the timing of the cash, the amount of cash, as we talked about earlier, that's tied up in assets. And that could be physical assets like factories and land and labs, but it could also be working capital, which is sort of the example I gave you around timing. And so as we think about this sort of growth of the business, we want to be thinking about making it as asset light as possible early in the life of the company, de-risking and learning about the potential, and then scaling it up at a later point. So the first VC firm as we know it today actually arose in the mid-1940s. It's the American Research and Development Corporation. But yes, venture capital as a really well-established institution really began to take off in the late 1970s, early 1980s, with the advent of the semiconductor revolution and the biotechnology revolutions, and then really came into its own around the internet era, where there was a massive amount of capital that came into play. Now, of course, those are recent technological revolutions, and we have had several technological revolutions in the United States going back, hundreds of years. So my colleague Tom Nicholas has actually written a history on venture capital and has traced back in many ways the origins of venture capital to the formation of intermediaries that were using risk capital in many similar ways in the mid-1700s and early 1800s. So for example, there were voyages that went out, whaling ventures that went out to actually hunt whales. And the organization of the way in which the ship captains worked relative to the people who deployed capital towards them was in many ways quite similar in the ways in which the risk and reward were shared between the various parties. And we can trace that all the way back to modern-day venture capital. There was obviously technological revolutions in the late 1700s, early 1800s. The cotton manufacturing in Lowell was today what Silicon Valley is in many ways. And then we had steel and rubber and motor cars, so moving to Cleveland and Pittsburgh and then to Detroit. These were all incredibly technologically advanced industries and cities in their time. And we have histories of angel investors in these regions in the Midwest. For example, Andrew Mellon was, I think, one of the Secretary of the Treasuries at the time, but was an active angel investor in the Pittsburgh, Cleveland area. And we know for a fact that the investors in Ford, Motor Company, in Westinghouse, in General Electric, these were all backed by angel investors at the time who really helped commercialize those technologies. So in many ways, the history of risk capital in the United States has a very long history, but the ways in which risk and reward were shared, the ways in which cash and control rights were developed have evolved over a reasonably long period of time, but the modern-day institution of venture capital, as you point out, is relatively recent. We've also had family offices. So Venrock, for example, was a family office. It was a venture firm that evolved from the family office of the Rockefellers. Bessemer Ventures evolved from the family office of Phipps, who was involved in the steel industry. So those are all interesting examples of how venture capital kind of traces its lineage to a long history of angel investors and wealthy individuals who were making pretty risky investments in their time into what was, at the time, very, very interesting and novel frontier technology.
The SBIR was so important to our founding. Without ICOR, we would never have found the food and beverage market as a place for us to get started. Without ICOR, we would have never structured our company culture to be totally customer driven, and that was incredibly foundational for us. The SBIR and grants in general really force you to think 3 years out in a way fundraising from investors doesn't. Because you're putting specific milestones down and you're putting specific budgets to those milestones. And when you do that, you really do think about technology risks in a different way. And that has been incredibly valuable for us as well. We learned some things so when we first wrote our SBIR, we said this is a list of experiments we're going to do. And it turns out about 80% of those were really very directly relevant to what we wound up doing. And that last 20% was, okay, well, we have to complete these experiments in order to fulfill the grant, even though they're not directly relevant to where we narrowed our focus. But we learned things. We got data that we weren't expecting that helped us shape where we were going next in a number of different ways. So we were fortunate. We could have gotten data that was totally not relevant, but in that case, we were able to benefit from that as well. And I think the SBIR program is, it's America's Seed Fund is what it's called. And it's called that for a reason, because I think it enables hard technologies a runway to get things done and to fund development that is very, very difficult to fund with private investment.
What I tell all of my founders who come to my program, who I guess technically have raised some money by coming into Techstars and giving up some small amount of equity, I tell them this. I say, you have 100% of your own brain. That's all you have. You don't have any more. Any percentage of your brain that you dedicate to finding investors, pitching investors, selling investors, closing deals, and then managing investors after the fact is a percentage of your brain you can no longer use for understanding your marketplace, understanding your product, perfecting your product, essentially advancing your product to the customers who are paying for the product. So I give them a stark choice. You can either dedicate your mental capacity to selling chunks of equity in your company to investors, or dedicate that same mental capacity to selling your products to your customers. Which do you prefer? And it really is an A-B decision. Some companies cannot avoid raising money because they have a product that they're making, a hardware product or something that simply requires a very large amount of capital to make the MVP. But in every other case, if MVP meaning minimally viable product, in every other case, if a company can possibly reach minimally viable product without taking money from an investor, I strongly encourage them to do so. I also strongly encourage them to find those customers who are willing to pay in advance for some access to a brand new product or some discount on the product in the long run, if they're willing to share some of the risk and partner with the company by paying them in advance. This is where the Department of Defense is fabulous at providing a lot of advance capital to small businesses to advance their product, to prototype their product without taking any equity. And in my program, I'm an extremely strong advocate of all of my companies bidding and winning government small business contracts, especially the SBIR program, and using that capital to replace their seed round and to develop their MVP on non-dilutive government contract money. Again, this comes down to finding a few key customers that will say, wow, my pain point is so high that I'm willing to take a risk on this little nascent product and this little nascent company by offering them a purchase order to buy the thing if it meets these certain performance criteria, performance requirements. If you get enough of those, that indicates that there's, where there's smoke, there's fire. If enough of these customers confess their pain point in the form of a purchase order, an advanced purchase order to pay in advance, this is a strong indication that there is demand out there, and one can parlay this into some level of company that can be successful. So that's the best indicator. Somebody's willing to pull cash out of their pocket and pay in advance of the product being done.
We have institutional investors, so we've raised money from a number of venture capitalists, some in the US and some abroad. And then we have strategic investors. So for example, this big advertising conglomerate who, they invested in Affectiva because they're interested in a return, but more importantly, because they want to bring our technology into their company. And so usually the investment, if it's strategic, it's paired with a commercial agreement. So that was great because now we had an investor, but we also had a commercial revenue opportunity. So that was helpful. And then examples like the National Science Foundation Small Business Innovation Research Grants, which are usually, they're smaller in amount. They're usually, in a couple of $1 million. But it's no strings attached, right? They're not getting any equity, and they usually don't really... You have leeway in terms of how you use the funding. And it gives you a lot of credibility because these grants are pretty competitive. So early on when we got the National Science Foundation grant and then we went out to raise money from venture capital, they were like, oh, you have an SBIR grant? That means the technology is credible. So that was helpful. So then I'll kind of tackle how do you find these investors? It is amazing if you put your minds to it how connected we all are in this day and age. So it wasn't actually hard to get investor meetings. I mean, we're particularly lucky because we're part of the MIT network. And so tapping into that community of entrepreneurs as well as investors who are connected to other investors wasn't actually that hard. We were able to get a first meeting every single time. But it wasn't easy because it was myself and my co-founder. We were both female scientists, right, with actually no industry experience. And we were raising money to start an emotion company. And we were pitching to mostly older male investors. So it wasn't easy. But we persisted, and we were able to raise, substantial amount of money from actually top-tier investors in the world. So persistence is key. And I will say that we ran into a number of investors who wanted to invest in Affectiva, like that security agency, but we felt that our core values were not aligned. There was also one case where we had to choose between a traditional VC and this international VC that wanted to see us explore and kind of have presence around the world, especially in Egypt, where I originally come from. So they were very excited to have us start a Cairo team. And so that was an example where, maybe they gave us less money, but they were more aligned with our vision and they were in it for the long term. They weren't just interested in investing in Affectiva and then flipping us around and selling us to somebody else. That was important to us as well. We were raising money in 2009. I think the world has changed, so people today understand that your emotions matter and emotional intelligence is really important, and it's especially important in a digital world where if you look at the public discourse in politics and socially, it's really sad. People aren't being empathetic and humane anymore, right? And so I think there's a need for emotions today, but that was not the case when we spun out. And we used to actually call it the E word, and we would never talk about the E word publicly, right? So we would find, and that's actually why we called it affectiva. We didn't use the word emotions. So we looked for synonyms, and affect, affect is a broader kind of umbrella that encapsulates emotions, but it doesn't use the word emotion. So it was definitely interesting. And again, you could tell that we were fighting, because all the investors we met always found our technology fascinating. And so there was always this curiosity about what we're doing. But also, I think we just looked so different than their typical kind of entrepreneur that they see pitched to them. And so it wasn't always easy. I also think I was on a huge learning curve. So I'll give you an example. One of the investors that we were courting sent us an email, and it was exactly this. He was like, "Send me the BS." And I was like, the only BS I know just doesn't make sense in this context. And so we emailed a friend of ours who was a mentor of ours actually at MIT, who had a lot of business experience. I was like, "What does BS mean?" He was like, "Balance sheet." I was like, "Oh, okay." So we sent the investor the balance sheet. But examples like that, right? Like I just, it was a very steep learning curve. There were a lot of things that I just didn't know about. And I mean, examples also include like valuation and liquidation preferences and, is it stock options or restricted stock awards, right? Like all of these things that I just had no clue about. So I had to learn very quickly. It was exciting because it was an opportunity to learn about stuff that I had no idea about, and learn very quickly because we were doing it as we were going, right? I couldn't just take 3 months to learn about all of this stuff and then come back. You just had to learn on the go. Yeah. And so my advice around that actually would be to find mentors and champions, personal mentors who, you could ask these silly questions and not feel like it's very embarrassing. And they could provide kind of real-time help. That's important.
Yeah, I think one piece of advice that I often give, particularly scientists and engineers and technologists, is that it's really important to be able to get an understanding of what the consumer is looking for. Oftentimes, scientists and engineers build what they think is the perfect product from their standpoint, but it often doesn't solve a specific pain point that the consumer is looking for. And then they end up getting frustrated when there isn't as much traction in the market. And so as we think about the distinction between invention and innovation, in my mind, what's particularly valuable about innovation is taking an invention and commercializing it and making a successful company that people out in the real world are willing to pay money for. And there's a big distinction between those two. We might have a great invention that we haven't figured out how to actually bring to market in a way that customers are able to see the value of that invention, are willing to pay for it, and that you are able to make money from it and raise capital for it. And so I think one big piece of advice I like to give people who are building these kinds of particularly science-based companies is to think carefully about getting customer validation early on and being willing to tweak their product and their invention in a way that they might not have thought of would be perfect from a scientific standpoint, but might still be much more valuable for what the consumers are looking for. I think the second piece of advice I would give is to think a lot about building a company as the sequence of investments and experiments over time. That turns out to be a very powerful lens to approach both product development and financing, because it helps you focus what you're doing in any moment on what you need to convince the next set of people in order to be able to get money. And so there's millions of things you could be doing as you're building a company, and it's hard to know what to focus your time on. But as you think about this framework of experimentation. As when you're in the Series A round of financing, you raise that money to be able to run some experiments. And what experiments? What do you do with that money? You do things that will help you convince the Series B investors that you have de-risked the company to a point that warrants you raising Series B round of financing. And that's a much more focused and powerful ways of kind of bringing down the set of possible things you could be doing to a very clear set of milestones. If you know what the Series B investors are looking for, you can then help to achieve those milestones and run tests in your own company that will provide data that will say, look, I have these churn rates, I have these growth rates, I have this unit economics. These are the kinds of things that you were looking for, and I can demonstrate to you that I am actually doing very well on those.
Congratulations. You've done the hard work and you've now completed the course. There's some things you want to keep in mind as you think about the next stage of how you're going to take the lessons from this course and apply them to yourself. The first thing, of course, is to think about innovation as a systematic process of matching needs with seeds. You've learned many aspects about this process. You've also learned that anybody can be an entrepreneur if you follow a systematic process. And you've learned the importance of generating lots of ideas and getting them validated by the marketplace. These elements come together to help you accelerate innovation. We've been fortunate to have many guests participate in this course with us. They've provided us with diverse perspectives. We've had people with long and distinguished careers, new entrepreneurs, experienced investors, and inventors. And you can take their wisdom to help you propel towards the next step of taking these seed technologies, figuring out a way to create a business around them, and then raising the funds to launch them in the marketplace. There are many resources to go pursue this in your own geographies, in your own industries, and we encourage you to look through those resources and take the next steps to take your ideas, take your concepts, and bring them to the market. As we have highlighted in the course, society invests billions of dollars in research and development and looks to entrepreneurs to take those investments and those technologies that have been created and bring them to the market and solve real-world problems. We have problems in climate change, in food scarcity, in water access, in income inequality. All those things are ready to be solved if entrepreneurs find the right mix of seed and match it to the needs. It will require you to take the risk to make this happen. Thanks once again for participating with us in this course. Nubar Afeyan, thank you very much for joining our course. Please tell us a bit more about yourself and your role as CEO and founder of Flagship Pioneering.
Sure. Well, thanks for inviting me. I've been involved in innovation and entrepreneurship in the life sciences for about 31 years. I did a PhD in what was then a new field, biochemical engineering. And since then have found different ways of deriving value from making breakthroughs in that area. And initially, I followed the kind of traditional route of developing technologies, raising capital, and developing startup companies, venture-backed startup companies. And then more recently, what Flagship Pioneering really specializes in is in a different way of thinking about both innovation and entrepreneurship. And we're looking to systematize the process and make it something that an institution can do instead of a group of individuals.
Great. So tell me first how you got the bug of taking technologies and bringing them to market. What was the spark that got you on this journey?
Different people are inspired by different things. In my case, it was actually quite memorable. I had no intention or no idea in 1985 graduate students, let alone, kind of not from this country, didn't exactly think that they were going to go off and start a company. That's a pretty recent phenomenon in the last 15 years or so. But so I was a graduate student working in a pretty esoteric kind of project. And I happened to find myself at an NSF conference that MIT had sent me to. You have to remember, in the 1980s, the U.S. was worried that it was going to lose its competitiveness against Japan, and there were all these kind of meetings about how are we going to compete with Japan, etc. And they must have needed somebody who knew how to spell biotechnology, so they sent me down. And at this conference, which was otherwise utterly boring, I happened at lunch to sit with somebody, and I got enough courage to ask him what he did and who he was and stuff. And he started telling me how he had started a company some 35 years earlier with another friend of his, and they were a new breed of engineer. This was electronic engineer. They came out of the power industry. And I was listening to his story, and it's just kind of I had nothing to relate to. Except when he said new breed of engineer, I kind of thought, well, that's interesting. I'm a new breed of engineer, and engineers had not done biology ever in the past. And he said, they didn't know what these engineers would make, but they knew they would need to measure whatever they made. And so he and this friend of his started this effort to make an oscilloscope in their garage. And they started selling it to their friends. And then that led them to make even more products. And so it's kind of interesting. I had no idea who he was, but it was interesting to relate to. I was a new breed of engineer. We didn't know what biological engineers would make, but we did know that they were going to need to measure things. And so, probably out of a deficiency of fairly linear thinking, as engineers sometimes have, I was just mapping it to me, and I was saying, oh, that's interesting. And then I asked him who he was, and it was David Packard from Hewlett-Packard. And he spent the next couple of hours telling me, just one-on-one, as just, out of, I could have been sitting in a park bench with the guy. I mean, he was literally just very relatable. And literally, I came back to MIT, to my graduate, kind of lab, and then I thought, well, how am I going to figure out how to do this? I really wanted to do this. And I went to Sloan School and said, can I take courses? They had absolutely no courses on entrepreneurship at the time. Now everybody has 1,000 courses, but it was not something that was taught. So that's when I actually started finding my way to Eric von Hippel's class and to several other people's class who were teaching management of technology, innovation. There was a corporate venture capital course I took, I don't know why, all to just kind of get myself introduced to that. And that's kind of how I started. One of the things I've learned over all these years I've done this is that sometimes people make entrepreneurship some kind of almost like art or science, or there's almost celebrity associated with it, and I always resent that because it makes it unrelatable. It makes it look like when I like playing basketball, but when I look at Michael Jordan, I realize I'm not going to be him.
Yes.
And those kinds of celebrity figures don't encourage the sport. They actually discourage the sport.
Yeah.
I mean, without wanting, because you say, I'm never going to be that.
Yeah.
Well, here was a guy who was clearly a celebrity in doing that, but he was absolutely no different. And what he impressed upon me is that if I was willing to kind of stick with it and iterate and learn and adapt, he didn't give me any other tidbits. There wasn't that much to give. So I think, and since then, part of the reason I teach, and I've taught for the last 17 years, various aspects of entrepreneurship innovation, is just that. Because I realized the more people realize that this is not some kind of, kind of high-browed activity, the better the economy is.
So tell me, from that inspiration to your first startup.
In 1987, which was a couple of years after this meeting, after I had kind of exposed myself a little bit to what innovation and technology was, and without really an idea to start a company around, as I was getting close to graduating, I started thinking, well, I should really keep that as an alternative in mind. I went out and met a startup company that was then just forming out on the West Coast, realized that being employed in one wasn't kind of the same thing for me, because I realized other people were trying to figure out what needed to be done, and I was going to execute it. And while that was interesting, that I didn't consider that to be the same thing. And so I started kind of trying to figure out, okay, if I was going to do this, what would I do it with? And pretty linearly, I thought, okay, what about making instruments for the biotech industry? Just like these guys had made instruments for the electronics industry. And started looking at, okay, well, what the needs are. So it's kind of a pretty kind of classical way of thinking about user unmet needs first, which again for a technologist wasn't the first thought they come to mind. But the folks at Sloan had impressed upon me that far more interesting than finding customers for what I could do was finding problems that were worth solving. And so I looked at a bunch of different things where we could apply engineering mindset, problem solving, and there were many because the field is so new. And whenever I always find that if you're working in a field that's rapidly changing, there's an innate advantage that if you're a newcomer, there isn't that much difference between you and the current players because they also haven't been at it that long. So that's how I started. So I basically wrote a business plan as I was graduating from MIT. My first meeting with a venture capitalist was, I think it was something like October 30th or something like that, 29th, I forget the exact date, in 1987, which happened, I remember very well. It was a Tuesday because it was the day right after the stock market crashed. Yeah. So the Monday that the Black Monday that occurred.
That was October 19th.
October 19th. So it was the day 20th. After, October 20th. And I remember having set up a meeting, going to see at the time famous venture capitalist Ginger Moore at Oak Ventures, who in the life sciences area is one of very few people who invested. And I went to see her, and it was kind of quite a stark memory because I was 24 years old and I had the business plan and I didn't know what I was doing. And here was this person who had done this for 20 years already, and she was completely frazzled, lost, kind of devastated at what was going on. And I thought, boy, this is it's a weird introduction to the field. It was the best thing that happened to me because, frankly, 31 years later, even in the last few days, the feeling is quite similar. And so one thing I learned back then is that if you have a calm day, it's actually not out of character, but it's usually just very turbulent. But anyway, and it also tested me because her advice to me was, you look like you can do this, you've got a good idea, but you're never going to be able to raise money for the next year. Go do something else, because the market had been devastated. And it was interesting, and so that forced me to. I didn't take her advice, but at the same time, I did realize it was going to take a while to be able to raise money, and so I started trying to. I got a side job at MIT doing technology licensing for a year. My professor was generous too. They needed somebody to do some licensing work, and I continued to develop the business plan and got a lot of help from Ed Roberts, who's a kind of quite a legendary figure in entrepreneurship. And about, let's say, maybe almost a year later, I ended up getting some seed capital from quite unlikely sources, meaning just random people. I had met 100 different people. I used to think, and this may be useful for your audience, at the time I used to think that if I'm just successful ultimately, I felt like a beggar. I mean, that's kind of what it feels like. I had absolutely nothing. Yes. I had no technology. I had a piece of paper. I had my background.
Just the idea.
Just the idea. Yeah. There was no proof of concept. There was no technology I was licensing. Nothing. I just I had an idea. I'd filed a patent. And it was the closest thing to begging. They have it. You don't. You need it. Yeah. They may not need it as much. And the chance that I'm going to give them anything back is pretty dubious. It's a similar act. And I was telling myself, if you're successful, then you don't have to beg anymore. Yeah. And 31 years later, I realized that if you're successful, you beg for more and more. But that feeling doesn't go away, because anytime you're trying to kind of pre-sell the value promise of innovation that isn't proven, and then eventually realize it and reward people, it's an extreme form of fundraising, and that's kind of what comes with the territory. So I ended up getting some seed capital and started this company, which ended up growing over some period of time. By '89, we raised some venture capital money. This was, again, the old days of where venture capitalists used to put $100,000, $300,000 in, and then at the most $1 million, $2 million in ever. So it was not like there was not seed capital. Seed capital back then was $25,000. So at the end, this company called Perceptive Biosystems ended up raising $11 million from 7 venture capital firms, of which some venerable firms like Venrock and Bessemer and Highland Capital were the big investors, and there were 3i, the Bank of England. I mean, it was crazy that they were all putting in $500,000, $1 million. And ultimately, the company actually took off. In '92, we went public. In '97, we had about $110 million in revenues. We became a very established player and leader in the protein analytical instrument field. And so that was that journey. It was every day was as exhilarating as it was terrifying.
Yeah.
And now this is a well-trodden road. But back then, I remember very clearly the most recent company that Inc. 500, we were on the Inc. 500 pretty early on, had featured was Lotus.
Yes.
And of course Lotus had subsequently kind of been sold and disbanded, and it was before that it was digital. So it wasn't like there were all that many companies to say I want to do that. You had to figure it out yourself.
So you went through this journey, you have an idea, you incubate the idea, you persist, form a team, you raise capital, you go public, then you're back for more. So it's not one and done for you. This has become a lifetime. This is so tell us this transformation. So what that was and what caused you to sort of think about this?
Sure. Well, so first I'll go back to the perceptive thing, because one of the things you realize is that I ended up wanting. I mean, I did this largely because I wanted to learn how to do it, as opposed to the rewards of doing it or a lot of other things. I just thought it was so unlikely that I could pick up the minimum needed to be able to succeed minimally. That was a real adventure. So I wasn't a good manager. I'm probably still not a good manager. I didn't know how to raise money. I didn't know how to hire people. I knew even less about how to fire people. Excruciatingly painful to do for the first time. I had hired a bunch of experienced people early on. The one thing I learned that I think is quite kind of ageless in terms of a lesson, I use it to this day, is that especially when you're young and when you're not expected to know much, the fact that you actually use that to ingratiate yourself to people so that they help you in helping you figure out something is a really powerful source of kind of borrowed intellect. I mean, you cannot have wisdom, early on.
Yes.
The next best thing is to admit it and to let other people give you their wisdom. And by this, I don't mean advisors and mentors. I just mean people who just kind of like you and decide that they want to help you succeed. There's a lot of people out there who, as long as you give them, it's like permission marketing. This is like permission advice. If you give them the permission to give you advice, and they see you use it, not that they go, okay, I'll take that into consideration, but you truly kind of, let go of pretending that you know a lot.
Yeah.
And I didn't have this problem because I literally didn't know a lot about anything. My PhD had nothing to do with what the company did. I knew the language, but not much. I had no connections. I was an immigrant. I came originally from Lebanon, escaped the war, went to Canada, kind of grew up in a foreign place. So I had zero expectations, zero entitlement. I was not even American. I was Canadian. There was a lot of immigration issues back then, of a different kind. It was very hard to get papers here. There was no H-1 visas were like a new thing, and so it's interesting in hindsight when you look at it. But anyway, so that so learning how to manage, how to create business strategy. I never, to this day, I don't quite know what strategy is when it comes to a startup, because you have 100 different things you could do and 100 different ways of doing them, and choosing one, I suppose, is strategy.
Yes. Strategy is about choice.
That's what I mean. It's about choice, but in this case, there's like nothing else. It's a bit of an arbitrary choice in the beginning, uninformed choice, followed by lots of iteration. That's what I've learned. Anyway, but before getting to kind of what I do now, what ended up happening is in '94 or so, this company, I had iterated enough and made enough mistakes that I had a pretty good team. The revenues were growing. We were expanding. And, for the first time, I started realizing that, okay, I kind of sort of get it. And I became interested in innovation and value creation again. And I realized that in this company, which was by that time about 400 people, it's really hard to get rewarded for innovation. Because even though we were little, we were already too big.
You were already focused
for that. We had a line of products, and there's so much more we could have done. So I started actually experimenting with innovating with other people and helping other people start companies. So I was still running this first company, I was CEO of a public company, but I was able to, and when my board knew it and were supportive of it, I was able to get involved in a few other companies where people were, either they had a notion or an idea, but by now I was a little experienced. And so, ironically, they were looking for my experience, and here I was still winging it. And so in the 90s, kind of between 94 and 97, I got involved in about 4 other roles as a co-founder of companies. One was a drug discovery company that I ended up being chairman of, and we raised capital from a number of other venture capitalists to grow a very successful company. It was sold. We started a cancer diagnostics company, started a cancer vaccine company. And I found
this sounds like an addiction. Like you were just starting companies.
So it was interesting. No, I'll tell you, this was interesting. I was not doing it alone. So I had gone from founder to co-founder, and co-founder is a more scalable role than founder. But at the same time, I was not an investor in these things. I hadn't taken any money out of my first company. But I'll tell you why I got interested in this is that at the time the only kind of entrepreneur there was one and done or a serial entrepreneur. And I had thought kind of skeptically around serial entrepreneurship. I didn't know anything, but I always thought, well, why? If you've built a lot of value, what is there to show by doing it again and again and again? A silly thought, but I thought, what about parallel entrepreneurship? And back in the 90s, I used to go around telling people, entrepreneurship should be parallel. It's like parallel chess, where people play simultaneously multiple people. I always thought that's incredibly hard compared to playing one game. It's hard enough to play one. Yeah. And I must say that actually was just a kind of a hypothesis that led to what I do now, because as I tried to do that, I realized that when you're doing something in parallel that isn't as defined as, let's say, calculus or something, it's not a discipline yet, it forces you to focus on the essence of what you're doing and not all the idiosyncrasies of every single case. So I started kind of forcibly to say, okay, what can I do if I'm spending a few hours a week on a project that in and of itself wants to change the world, but my role in it, my involvement in it has to be strategic, surgical, highly leveraged, but not, infinite involvement of time, which is what you do when you're doing one company. Yeah. And so those experiences kind of in the end, the first company went public and it was sold 5 years later. The 3 of the other companies went public. 2 of them were sold, and this is now in 97, 98. And eventually I kind of started getting more intrigued by parallel entrepreneurship, and I thought I would devote myself to now going the next step, which is to say, why don't we if you can do this in parallel, why not do this institutionally? Because the next step there is it a solo game or is it a team game? And that's kind of what led to the thinking that led to Flagship.
So tell us what Flagship does.
Yeah, so that's Flagship. Flagship is first and foremost a life science innovation company. We have our own way by which we innovate, which I'll tell you about. Yeah. Once we come up with something that's worth taking forward, we form a company to take that forward. And so we also had to figure out how to do venture creation in a systematic way. We have our own capital, then we deploy into these companies to help them grow for the first 2-3 years. So up until then, they operate as wholly owned pieces of Flagship. And then we spin them out. And we spin them out, and for the first time, additional capital comes in. But by that time, the culture, the senior leadership team, the early proof of concept, the early kind of customer or partner traction is there. And it looks like a company ready to eventually live its life on its own. So we're not interested in building kind of subsidiaries open-endedly. Every single thing we do ends up becoming a company or nothing. Yeah. But so we've become kind of a creator of companies around internal innovations. Now, sometimes these innovations draw from external science, and I can describe that. Yes. But we're not only trying to find science and then find what to do with it and create companies. That's become in vogue the last few years. We've been doing this for 18 years. But we've ended up in a place where we think the sustainable way to do this is to have your own innovation capacity, your own company creation capacity, initial growth, and then the companies have the wherewithal to grow and compete and thrive.
That's fascinating. So walk us through one example of a company that you guys have given birth to from the start to, it's leaving the flagship full.
There are many. I think we've been involved in doing about 50 of these that are based on internally developed science, and there's a whole bunch more that also include external. But I'd say one of the internally developed ones that just recently went public, I can give as an example, is Moderna. So Moderna was and I'll tell you kind of this. We have this fairly, let's say, prescribed process, which the way people think about entrepreneurship and innovation, especially breakthrough innovation, is that it is unruly, it is chaotic, it is inspired. And
serendipity.
In my view, it's none of those things.
It's none of those things.
Absolutely none of those things. I have a completely contrarian view of that, and I've done it enough times in enough different fields that I think, frankly, just to be a little controversial, I think that's an illusion. In other words, I think that because people haven't done that thing before, it's exciting and unexpected to them. But actually, pretty quickly, it looks like just another version of what came before them, because the historians come and say, well, before there was the iPad, there was the iPod, and before that there was the Walkman, etc. And also, when you look at it that way, you go, well, why were you surprised? And that's when you realize that these things are just evolving. And so I'll give you an example in this company called Moderna, but before that, I'll tell you that underlying how we think you can do this systematically is the notion that breakthroughs aren't made by people, they emerge. And the most understood, not well understood, but understood version of emergence that we know about is evolution, which is that if you do variation, iteration, selection and iteration systematically, the winners will emerge, and when they do, they will look surprising, but actually they're the result of that process. They're not some inspired thought that has nothing to do with that process. So hold that thought as I give examples. There'll all be examples of that. And that actually does cause, one to think differently about being possessive about all these companies and all these innovations. We're not. We don't go around saying we invented this. We may file a patent and get an invention, but where these ideas come from are very emergent.